This is Marathon 3. Are you able to hear me? Please mention. Am I audible to you all? Reload करना एक बार. Okay. So we are back with the third session. And yes, this third session is going to be a mega session. As I mentioned, we are going to solve 250 questions and 250 questions from, you can say, the chapters which are actually of high weightage. If you see magnetism, I'm going to cover moving charges and magnetism. Okay, EMI, AC, EM waves, optics, modern physics, semiconductor. Semiconductor also we can say almost certain there is one question. Modern physics portion is also of good weightage. Optics, ray optics is high weightage topic, and with that wave optics is also decent, you can say weightage. EM waves is there, which is one of the easiest topic, at the same time the topic which have questions. Okay, so EM waves is where it is, yeah, is also important topic. And we have AC, it is also having good weightage. EMI is very important, and moving charges and magnetism I already mentioned. Hello, good evening. I'm Kerala and I'm ready to 250 questions. So that's great. Let us see how many of you will be there during this entire session, and let us see how long it will take for us. I'm planning to complete this by 12 midnight. Okay. Good evening, Dubai. Yeah. Arpan, good evening, Arpan. So let us see how many of you will be there during this entire session of 8 hours. And yes, it is worth. It is worth. Okay, this entire session will be worth because I am going to cover almost 30% of the weightage of the entire syllabus in one go, with the good collection of the PYQs. Okay, all the PYQs that I am going to discuss here are, you can say, segregated accordingly. Okay, there is no repeated concept like those type of things you will not find there. Okay, so good PYQs, and yes, we will try to touch the concepts also. Good evening, Arpan and Dubey. Okay, so let us start the discussion. By its Savitt law, I'm not going to derive the things and all, but yes, I'll tell you a few of the formulas which are very important. If a current carrying wire is there, carrying current I want to find magnetic field at a distance A perpendicular to it. Here it will be mu naught I by 4 pi A sine of this angle. Let us take this as phi 1, this is phi 2, so sine of phi 1 plus sine of phi 2. Okay, if this is an infinite wire, phi 1 and phi 2 will be equal to 2. Okay, 90, okay, infinite wire, then it will become mu naught I by 2 pi A. If it is a semi-infinite wire, then it will become mu naught I by 4 pi A. Okay, if there is 30, 60 or like that angle, accordingly you can take. Now phi 1 and phi 2 can be negative, positive also. How I am saying? If the wire is like this, then your phi 1 will be negative, phi 2 will be positive. So accordingly you have to take the values of phi 1 and phi 2. Now next important formula is magnetic field on the axis of a current carrying loop. Here radius is r. Let us take it as carrying a current I. On the axis at a distance x, the magnetic field is mu naught I into r square divided by 2 into r square plus x square to the power 3 by 2. Okay, and if you put x is equals to 0 here, it will become mu naught I by 2r. So at the center the magnetic field is mu naught I by 2r. This is important formula. Okay, this is very important formula because many times it is direct questions are asked from this, and many of the students get confused. Okay, where r square is there, where x square is there. So make sure you remember it. Good evening, Arpan. Now magnetic field due to current carrying conducting wire of infinite length I discussed. Due to current carrying circular loop I discussed. Magnetic field on the axis of a circular current carrying loop. Yeah, Now coming to the questions. These type of questions you will find. It's a combination of circular loop and straight line. Many of the questions you will see, okay, there is a triangular loop kind of thing, there is a square loop kind of thing, there is a combination of semicircular and straight wires like this, there is, here you can say these two are infinite wire like that. Yeah. Now when you have to write magnetic field at P, so what you can do is, due to each of the conductor, take the contribution and add it. You have to check the direction also, okay, and accordingly you have to take the resultant. Now see, this is one conductor, this is next conductor, let us take this is 2 and this is 3. Now due to 3, if I say the magnetic field at P, that will be 0. Why so? Because it is passing through that. So it will not contribute to the magnetic field. This will not contribute to the magnetic field. I'll say due to this the magnetic field is 0. Now due to this conductor, first, this is a semi-infinite wire at a distance, perpendicular distance r. If I write the magnetic field at P, that will be mu naught I by 4 pi into r, semi-infinite na, phi 1 plus phi 2, sine of phi 1 plus sine of phi 2. One will be 90, another will be 0. Yash Mathur, yeah. Okay, what is the direction due to this? Out of the plane. Okay, use right hand thumb rule like this. It is out of the plane, so k cap. Due to this circular, if it will be a complete circular, magnetic field will be mu naught I by 4 pi 2r. But if it is half, the magnetic field will be half of that. So it will be mu naught I by 4r. And what is the direction? Out of the plane, k cap. So this is due to this first conductor, this is due to the second conductor, and due to B3 we are getting 0. Now add these up. So mu naught I by 4r will take common 1 by pi plus 1 k cap. Mu naught I by 4r. Okay, I can take mu naught I by 2r as common, then it will become 1 by 2 pi plus 2. Sorry, 2 by pi plus 2. I think we did some mistake. Mu naught I by 4 pi r, that is there. And due to this part, it is mu naught I by 4r. Mu naught I by 2r due to complete, half is there, so mu naught I by 4r. And what is this? I think none of them is matching. Is there any issue? Mu naught I by 2r, if I take, it will become 2 by pi plus 2, isn't it? Sorry, not 2 by pi. Multiplying and dividing with 2. So this is 2 plus 1 by, wait a minute, 1 by 2 I am taking inside, na? So 1 by 2 pi plus 1 by 2. If I write it like this, I think something is missing maybe. Mu naught I by 4 pi r, okay, due to that first part, due to this it is mu naught I by 4r. Yes, that is there, and due to this it is 0. So I am just adding that mu naught I by 4r, and I took as common. So this is 1 by pi plus 1, and from here if I take 2 inside, it will become 1 by 2 pi plus 1 by 2. There is something I think missing maybe, or maybe some typing mistake in this. I'm seeing again if there is any typing mistake error like that. Due to this it is mu naught I by 4 pi r. Yes, that is clear to us. If it will be infinite, it will be mu naught I by 2 pi r. Okay, half of that semi-infinite it is. Due to this it is passing through r, so due to this the contribution is 0. Now due to this semicircular, it is mu naught I by 2r due to complete, due to half mu naught I by 4r. So mu naught I by 4r plus mu naught I by 4 pi r. I think there may be something missing here. Let us move ahead. Due to next question, let us write printing mistake. Yeah, I hope so. All options same. Yeah. Why there is some printing mistake, therefore I am saying. Anyways, all options same. There is some typing mistake. Now, yeah, next question is this. All options, yeah, it was a typing mistake. Two identical circular wires of radius 20 centimeter carrying current √2 are placed in perpendicular planes as shown. The net magnetic field at the center is, okay, both are having center here only. What is the magnetic field at the center? Mu naught I by 2r. Okay, but these loops are perpendicular to each other. So due to, let us take, if you write due to this loop, the magnetic field will be in this direction. Let us take this as B1. Now due to this horizontal loop, the magnetic field will be in this direction, that is B2. B1 and B2 will be equal, mu naught I by 2r each. Okay, now I need the resultant magnetic field. These two are perpendicular to each other. The resultant will be like this, and that we can write as root of B1 square plus B2 square. Now you can take it as both are equal, so it will become root 2 times like this. Now put the values. Two identical circular loop, radius is 20 centimeter. Okay, the current is √2, so this is my I, this is my R, and what else? Nothing else. So mu naught, what is I? I is √2, so √2 into √2 here, divided by, this 2 is there, this will get cancelled, divided by R. R is my 0.2. Now mu naught by 4 pi, you know that is 10 to the power minus 7. So mu naught will be 4 pi into 10 to the power minus 7 mu naught value divided by 0.2. Now we can do the calculations and we can say what is the answer here. Next, okay, these type of questions are multiple times asked by NTA. Part of the circular loop, some angle will be given. Okay, these type of questions, you know. So if you have to write the magnetic field due to any arc, okay, which is making an angle theta, here you have to write magnetic field. Let us take this radius is R, this current is I. How will you write the magnetic field there? Now we know that due to complete loop, the magnetic field is mu naught by I by 2r. And each part is contributing equally. So if you ask me how much due to this part theta, so I will take the ratio theta divided by 2 pi. If theta is equals to 2 pi, means complete loop magnetic field will become mu naught I by 2 pi r, 2r. Okay, if theta part is there, take ratio like this. Now here what is our theta? Theta is pi by 4. So put here, so B is equals to mu naught I by, this will become 4 pi r into pi by 4. What it is now? This is mu naught I by 16 into r. Mu naught I by 16 r. I have to take due to each of that. Okay, now this is one part. Due to this part, the magnetic field will be 0 because it is passing through that O. So it will not contribute. This is 0. It is also passing through that O. It will not contribute. This is 0. And due to this, we will find. Now let us take, this is my B1. This is B2. So if I say B1, use this formula, mu naught I by 16 into R. What is R? R is 3 centimeter. Okay, what is the direction? Out of. Always keep that you have to take direction properly, otherwise answer will be wrong. Keep that thing in mind. So out of the plane, that is k cap. This is B1. Now write B2. So mu naught I by 16 into. Now it is into the plane. It is into the plane. And what is R? 5 centimeter. Minus k cap. Like this. Now take the resultant, add the two to find the net magnetic field. So if I write the net magnetic field, B net is equal to mu naught I by 16 thing, I'll take common. Rest 1 by 3 minus 1 by 5. Like this. And also this was in centimeter. If I convert that to meter, 100 will go in the numerator. 100. Okay, divide that with 100 now. So 100 will go in the numerator. So 100 here. like this. Now we will put the values here. What is I? This is my I. What is mu naught? 4 pi into 10 to the power minus 7. Okay, and rest all is the calculation part that you can do. Which price the Venn graph generator price in your city? Sonali, I don't know. Dubey, okay, you mentioned the answer for the previous question. Okay, that's great. Please solve the questions with me. Okay, I see many of the students, they join the C. Okay, teacher is solving some question and then they leave. It will not help. Solve the questions with me. If you solve the questions with me, it will be a great revision for you. And trust me, many of the questions you will see direct from here. Many of the questions. And not only that, if you get some question directly, that is good. But the level or the type of the questions are going to be the same. We have seen, okay, what NTA is asking now. It's a good collection for you all. So don't miss the opportunity, I'm saying. Don't waste it like, just watching some like that. Okay. Next question, two identical circular loop P and Q of radius R. Okay, this question was asked in 2026. You see, on the axis of a circular loop, many times these type of questions are asked. Sir, I have been secretly following you for 1 month, and really I had to say that you and other two teachers are the most underrated teachers at this date. Doesn't matter, okay, if you are able to take that benefit, okay, that's great. Even few students are able to take that benefit from our live and all, that's great. We know with time things will grow, because our this English platform is new and we have just recently started all these things. But still students are joining and taking benefit from the previous lives also. Many of the students who could not watch the live discussion, they watched in the recorded version, but at least students are taking benefit. That's good. Now coming to the question, P and Q, each of the radius are lying in parallel planes. Okay, they have common axis. Okay, this axis is the common. The current through P is 4I. Okay, sorry, for P is I and for Q it is 4I, respectively, clockwise direction as seen from O. So if you are at O here, if you see the current is going like this, current is going like this. So if the current is going like this, if you write the magnetic field, okay, from O you are able to see it is going like this. Okay, now if due to the current, if you see the magnetic field will come in this direction. So this will be the magnetic field due to P. This is the most important thing in this question to get confused with. Now from O you see in Q the current is clockwise, means the current is moving like this. If you write the magnetic field due to that, it will be in this direction. Okay, so the current is moving in clockwise direction, due to that the magnetic field in this direction. And here also the current was moving in clockwise direction like this. If you write the magnetic field, that is in this direction. So I got the directions now. I know the distance, I know the current. Now I will write the magnitude of BP and magnitude of BQ. Sorry, it was Q. First of all, write the formula for magnetic field due to a circular loop on the axis. In my time also, when I gave JEE Main exam, I think this formula was asked, if I'm not wrong. Hi sir, I'm late. Hello Kiran. Okay, at least you joined now. Now write BP. BP will be equal to mu naught into the current of Pi into the radius r square divided by 2 into, what is this distance, r. So it will become r square plus x square to the power 3 by 2. So 2r square to the power 3 by 2. So it will become r cube here, and 2 to the power 3 by 2 will become 2 root 2. What it is now? Mu naught I divided by 4 root 2r, like this. Now if you write BQ, here instead of current I will have current 4I, rest all the distances are same. So instead of I you write 4I. So this will become mu naught 4I divided by 4 root 2 into R. I need the net magnetic field. They are in the opposite direction. Subtract them. So B net is equal to, net will be in this direction because BQ is greater, and that will be 3 mu naught I divided by 4 root 2R. Towards Q, yes. Now it is correct. Okay. So the direction is the most important thing, and try to understand the clockwise and the anti-clockwise sense the way it is mentioned here. Okay, now Ampere circuitry law, you know, if there are current carrying loops like this, I1, I2, I3, if you take a closed loop, okay, like this, moving in this direction like this, so I'll say integration of B dot dl in this closed loop is equals to mu naught into the I enclosed will be I1 plus I2 minus I3. Okay, in the direction in which I am moving, those magnetic fields which supports for those currents, I'll take positive sign, for other I'll take negative sign, like this. Solenoid due to magnetic field due to a long solenoid, we need to remember the formula is mu naught Ni, where N is number of turns per unit length, and the same formula for toroid also. Coming to the questions, option B, okay, I think you are talking, yeah, here option B is there. Now coming to the questions, next question. The magnetic intensity at center of a long current carrying solenoid is found to be 1.6 into 10 to the power 3. If the number of turns is 8 per centimeter, then the current flowing through the solenoid is simple. What is given to us? Magnetic intensity. You see the unit here, it is ampere meter. So what it is basically? Ampere per meter it is Ni. Actually H is given to us. This is given, not B is given here, H is given to you. So H is 1.6 into 10 to the power 3, and this is number of turns per unit length. It is 8 per centimeter. Number of turns per unit length, I will write 800 in SI unit, 8 per centimeter. So 800 per meter into the current I. From here I can say what is my current. Okay, I hope you are able to understand this. Don't get confused. This is H. By seeing the unit, we can easily see this. Okay, if the unit will be would have been Tesla there, then I'll be saying this is B. Okay, it is ampere per meter. This is H actually, and generally we call magnetic intensity H as the magnetic intensity. Next question. Along solenoid, wire of radius A carries a current I. Okay, along straight wire of radius R carrying a steady current I, the current is uniformly distributed across the cross section. The ratio of magnetic field at A by 2 and 2A. Okay, so you can say this is the wire like this. It is carrying a current I. The radius of the wire is A. Now we need to find magnetic field at A by 2 and at a distance 2A from the central axis. At a distance A by 2 and at a distance 2A. So what we can do is, we can make the cross section like this. Here total current coming is I. Now for A by 2 means the point will be somewhat here. This became my Amperian loop. For this Amperian loop, if I say integration of B dot dl, that will become B into 2 pi into this radius. What is this radius? A by 2. A by 2 is equals to mu naught into I enclosed. If the total current is I, how much current will pass through this loop? Radius A by 2. I current is passing through radius A, where the area is A. This radius is half, area is 1/4. So how much current will pass? 1/4. So it will be I by 4. Okay, this is at distance A by 2. Now do the same thing for 2A. Now for 2A, if you take 2A point will be somewhat here outside. Okay, so when you will make the Amperian loop, it will be enclosing the complete conductor. So if I write here B into 2 pi into radius is 2A, this is equals to mu naught into I enclosed, like this. Okay, what it is now? B is equals to mu naught I divided by 4 pi A. What it is? Mu naught I divided by 4 pi a. Both are equal. Therefore, 1:1 is the correct answer. You see the difference? City intimation, they will come, don't worry about that. Sir, these days I have been doing the paper analysis by your team of Jan attempt for these last days since my syllabus is completed, and side by side I am giving mocks. What's your thought on this? Okay, paper analysis live, paper analysis you are doing. That's great. You can attend the live discussions also. Okay. Gaurav sir is taking, Dipendra sir is taking, myself, we are taking. So it's a good collection of the questions. We will have more marathons, okay, upcoming dates also. Almost, I think, except the paper analysis live, we will be having marathons. So you should come, attend the marathon, solve the questions. It will give you a lot of confidence. I'm getting some new approaches. Oh, that's great. If you are able to get new approaches, that's great. Option B is correct. No, option B is not correct. Option 3 is correct. See carefully. This is, I know what mistake you are doing. In both the cases, you are taking current same. No, I enclosed will not be same. For inner loop, I enclosed is I by 4. For outer loop, I enclosed is complete current I. This is what you are making the mistake actually. Okay. Here, I enclosed will be I by 4. Half area is coming now. Only half area you are enclosing. So current that you are enclosing is I by 4. Here you are enclosing complete conductor. So you are enclosing the complete current I. This is the point that you have to understand. Okay. And if you do accordingly, you will get both the magnetic fields equal. Okay. And here how the magnetic field varies actually. With the distance, you see the relation. Till the distance is equal to the radius A, radius is A, okay, the magnetic field linearly increases like this. After that, it decreases like this. So my A by 2 is here and 2A is here somewhat. Both are having the same magnetic field. Yeah, you got the mistake. That's great. Do you believe 1 year is more time to get 95 percentile in JEE Mains? If you are focused, don't target for 95 percentile, target for 99 percentile. First thing is there. If you are focused, 1 year is more than enough I am saying. Okay, getting 99 percentile and try to get, good rank in advance also. If you are focused, you can do very nicely, no problem in that, trust me. And if your focus is not there, one day you will study, then next 10 days you will do something else, and then again you will think, okay, oh, I should again come back on the track. Then again you will come back on the track, then 1-2 weeks again will go. If you study like that, if your mindset is like that, then things will not work, trust me, then things will not work. Then you should avoid drop. Okay, then you should go for plan B, C, D, whatever plans you have. Next, magnetic force on a moving charge. Okay, how we write the force? Q V cross B. Okay, if the charge particle is moving parallel, magnetic field will apply 0 force. If velocity is 0, it will be 0. If charge is 0, it will be 0. If magnetic field is 0, it will be 0. Total force, if electric field and magnetic field both are there, so when we write the net force, we write due to each of them, due to electric field also, due to magnetic field also. Okay. Now, motion of a charge particle in magnetic field. If let us take magnetic field is in this direction, the charge particle is also having velocity in this direction, it will move in straight line. If the velocity is in this direction, the magnetic field is perpendicular to the velocity. Okay, I'm taking uniform. So it will move in circular Q, V cross B. It will move in circular loop like this. Magnetic field, the time period and all we know, time period is equals to 2 pi by omega. Okay, V is equals to R omega, V is equals to R omega, R is equals to V divided by omega. Like this, we write the radius. If you are having magnetic field like this and the velocity is making a angle, let us take maybe theta. with it, then it will move in helical path like this. Okay, so one component will be parallel to magnetic field, another component will be perpendicular to the magnetic field. Due to perpendicular component, it will be moving in circle q v cross b. Okay, it will be moving in circular loop like this. Due to parallel, it will be moving, so it will move like this, like this, like this. So here if I write the time period, it will be same. Time period will remain the same because it depends on omega only. Omega is the same. Okay, if I write the radius, for radius we need to take the perpendicular component only. V perpendicular is V sin theta. V sin theta into m by b cube. That will be the radius. And if you ask the pitch, yeah, pitch is how much distance it will cover while doing one complete rotation in the direction of magnetic field. So that pitch is equals to the time period into V parallel. Time period is 2 pi by omega. V parallel is V cos theta. Velocity selector is a device, or you can say here what we do is we apply electric field and magnetic field such that for a particular velocity the two forces cancel, the particle moves horizontally, and for all the other velocities they will deviate. Okay, so and here the velocity, the electric field, the magnetic field, they are perpendicular to each other. Let us take a particle is having velocity v like this. Okay, and let us take here the magnetic field is this. So q v cross b, this is my f magnetic. Okay, and electric field should be in this direction then. Okay, so the two forces are cancelling each other, so bvq is coming out to be E into q, so this velocity comes out to be E by b. This particle will move straight without deviation. Question was asked from this velocity selector thing. Do you believe, okay, I answered this. Sir, which bike you have, please tell now. Why you want that and how things will change? Why you judge a person by externals? Try to understand. Don't judge by these things. Okay, which bike you have. If I say I don't have bike, I have scooty, then what your mindset will be? And if I say I have a bike which is worth 20 lakh, then what your mindset will be towards me? If it changes, then it's not good. If it remains the same, then doesn't matter. Okay, an electron moves through a uniform magnetic field B, which is like this. At particular instant of time, the velocity of electron is this. If the magnetic force on the electron is this, okay, E is the charge of the electron, then the value of B naught is. How to write the force? Q V cross B. Okay, this is how we write the force. Now magnetic field is given to us, speed is given to us, we can write and we can find how much is the force. Here you say I cap, J cap is only there, K cap is not there. Generally, if you can say I cap is there, J cap is there, K cap is there, then we prefer to make the matrix, you know how to take the cross product, okay, then take the determinant of that. And if only I cap and J cap is there, one by one also you can do then. So let us try by doing one by one. So charge of the electron is given as E. I am considering the negative sign is inside only, okay. V is 3 I cap plus 5 J cap cross B is B naught I cap plus 2 B naught J cap. It is I cap cross I cap 0, I cap cross J cap, that is K cap. So what it will become? Minus 6, sorry, it is K cap plus, okay, this is 6 B naught, okay, K cap. Then J cap cross J cap will be 0, J cap cross I cap will be minus K cap, so minus 5 B naught K cap. Then what it will be? 6 B 6 minus 5 is 1, okay, B naught and K cap. What it is? Then the value of B naught is, okay, so this is given to us as 5 E K cap, okay, Newton. This is in Newton only. From here I can say B naught comes out to be 5 Tesla. 8 views. Why? Our channel is new. Sir, please मुझे इडली चाहिए. I don't know why you are spamming here like this. Let us solve next question. A proton and an alpha particle of the same velocity enter in a uniform magnetic field which is acting perpendicular to their direction of motion. Magnetic field is perpendicular to their direction of motion. It means particle is moving in circular loop. Yeah, this is what is mentioned here. The ratio of radii of circular path described by alpha particle and proton is, how we write the radius? V divided by omega. This is the radius. Now, same velocity is same, this is same, and uniform magnetic field is same, means charge and mass, they are different. So, if I write the ratio, circular path described by alpha particle and proton. So, radius of alpha divided by radius of proton is equal to, first is, it is directly proportional to the mass. So, mass of the alpha particle is 4 times that of the proton. Okay, so I can say 4m, mass of the proton is m. Then charge, it is inversely proportional to the charge. Charge of the alpha particle is 2 times of the charge of the proton. For alpha particle 2q, then q for this. Q is getting cancelled, m is getting cancelled. This ratio comes out to be 2. So, the ratio comes out to be 2:1. Okay, I hope this is clear to you. Next question. A beam of protons with speed of 4 into 10 to the power 5 enters a uniform magnetic field of 0.3 Tesla. Okay, at an angle 60 degree to the magnetic field. The pitch of the resulting helical path is, as I mentioned, pitch is equals to how much distance the charged particle covered in the direction of magnetic field while doing one complete rotation. So, that distance will be the time period of rotation into the velocity which is parallel to the magnetic field, like this. What is time period? 2 pi by omega. So, 2 pi divided by bq by m. What is V parallel? V cos theta. Now, we can put the values here. This is our V. Yeah. This is our magnetic field B, and angle is given to us as 60. This is our angle. Now, put it. Charge of the proton is also given. So, 2 pi into the mass of the proton 1.67 into 10 to the power minus 27 divided by B. What is B? 0.3 Tesla. So, 0.3 into Q is 1.69 10 to the power minus 19. Okay, into V cos theta. What is V? V is 4 into 10 to the power 5 into cos of 60, that is 1 by 2. Now, we can do the calculations easily. I hope this is clear to you. Getting it? Okay. Next question. A proton moving with a constant velocity passes through a region of space without any change in its velocity. Okay, means the velocity is not changing. It means the particle is moving in the straight line. It means what thing is happening here? The velocity is electric concept. You understood? Both the forces are actually perpendicular to each other. That may be there, that other things can also happen. I'll discuss actually. If E, B represent the charge and magnetic field respectively, then the region of the space may have. One thing is, if both are 0, electric field is 0, magnetic field is 0. Both will, any of them will not apply force, charge particle will go straight. This can happen, this is true, yes, it can happen. Next is, electric field is 0, but magnetic field is not 0. Can this happen? Yes, it can happen. It can happen like this is the magnetic field and this is the velocity. Electric field is 0. Electric field will not apply force. Magnetic field will also not apply force because velocity is in the direction of magnetic field. The charged particle will move straight. This will also be 0. Second is also correct. Vicky, hello. Abhishek, Vicky, Abhishek. The third thing, E not equal to 0 but V is equal to 0. Is it possible? Constant velocity. It's not possible. If B is 0, let us take, magnetic field will not apply force, but electric field is not 0, it will apply force. Charge particle will have some acceleration. Yes. So V cannot remain constant in this condition. This cannot happen. Third cannot be possible. Last option, both are not equal to 0. Is it possible? Yes. Velocity selector. This is the condition. The two forces are cancelling each other. Electric field force and magnetic field force are cancelling each other. Fourth can also happen. So here I can say first, second and fourth. All the three are possible cases. This is important conceptual question. You should be able to understand this. It can be asked in 2026 April attempt. Next, a proton and a deuteron, okay, having same kinetic energy enter a region of uniform magnetic field moving perpendicular to B, the ratio of radius. Now here kinetic energy is same. How we write the radius? Radius is equals to V divided by BQ by M. Can we write this formula in terms of kinetic energy? Yes. We know that half mv square is equals to kinetic energy K. Okay, so I can say that mv is equals to root of 2k into m. Okay, how? I wrote kinetic energy is also p square by 2m. P is momentum, mv. So p is equals to root of 2 into kinetic energy into m. This is my mv. So this is root of 2 into kinetic energy into m divided by b into q. Now see, when the charge particles are moving, what is same? Kinetic energy is same. Okay, this thing is same. Magnetic field is same. So my radius is proportional to root m by q here. Try to understand. Previously the velocity was same. There it was coming proportional to m by q. Now here it is coming proportional to root of m by q. Now see, ratio of radius of deuteron to that of the proton. So deuteron divided by proton is equals to root of mass. Deuteron mass is twice of the proton. Yes, deuteron charge is same as that of the proton, so charge is 1, so 1 is to 1, anyways that will get cancelled. So root 2 is to 1. Third option is coming out to be. Okay. Yeah. Next question. Next question is, a particle of mass m, charge q, has a initial velocity v naught j cap. So the particle is having velocity like this, v naught j cap. If an electric field E naught I cap and magnetic field B naught I cap. So electric field is also E naught in this direction. Magnetic field is also in this direction, which is B naught. Act on the particle, its speed will double after a time. Now due to magnetic field, the speed will never change. Due to magnetic field, the speed will never change because magnetic field will not do any work. Work done by the magnetic field is always 0. Why so it is always 0? Because here the, you can say, magnetic force is always perpendicular, q v cross b. It is always perpendicular to the displacement. Okay, therefore the work done is 0. That will not change the speed. That will not change the magnitude of the velocity. Only electric field can do. Now due to magnetic field, certainly if only magnetic field is there, it will move like this. Electric field will increase the horizontal component because that is in the direction of horizontal. So the velocity will get twice when if it is having v naught in this direction and it is having root 3 v naught in this direction. The resultant of the two will be 2 v naught. Therefore, due to this electric field, root 3 v naught velocity should come in the horizontal direction. This component will come due to electric field. Certainly, this v naught component will keep on rotating in the plane like this, okay, but magnitude will remain v naught only, and that will be always perpendicular to root 3 v naught, means the horizontal component. Now what is the acceleration in horizontal direction? What is the acceleration? Force in the horizontal direction divided by the mass. this is the velocity. Okay, I can say V x is equals to ax into t. I need time now. Yeah, I need time. Okay, so Vx is equals, what is Vx? Root 3 V naught. What is Ax? E naught q by m into t. From here I can say t comes out to be root 3 m V naught divided by q into E naught. It should be root 3 here. You can correct that. Clear? Next. Now magnetic force on current carrying conductor. How we write the magnetic force? So we write the magnetic force as I into L. Generally, like dF we write as I, dl cross B, like this we write. Okay. This is how we write the magnetic force. If magnetic field is uniform, then how we write it as? Okay, if magnetic field is uniform, then when I integrate it, B is constant, that I can take out. dl vector will give me L, I, L cross B, like this. But here you have to take the effective length. How it is? If let us take a current carrying conductor is carrying a current like this, and here magnetic field is there in some direction, but uniform. Now when you write the L vector, that will be starting from the initial point to this end point. This is my L vector actually. Therefore we call it as the effective length. Okay, let us take, it is mentioned to you, there is a semicircular conductor carrying current like this I. The magnetic field is B in this direction. How much will be the force? So what you will do is, you will take this as the effective length. So this will become my effective length. Join the initial and the final point of the conductor. Force between two parallel current carrying conductors. It was asked in 2026. There they mentioned 3 current carrying conductor. If there are 2 parallel wires like this at a distance d, you have to find force on one due to another, find the magnetic field due to one on the other, and then find how much will be the force due to that magnetic field. If let us take, this is I1, this is I2. If I write the magnetic field on I2 due to I1, that will be mu naught I by 2 pi d, okay, into I2 into that length L. So this will become my force, and force per unit length generally we talk about I1 I2 divided by 2 pi d. If they carry current in the same direction, this force comes like this. They attract each other. If they carry current in the opposite direction, they repel each other. Remember it. Same direction, attract each other. Very important concept. Torque on a circular current carrying loop. How we write torque? Torque is equals to M cross B. Okay, like for electric dipole, we write the torque as, how we write for electric dipole the torque? We write torque is equals to P cross E. Okay, instead of electric dipole moment, here we will have magnetic dipole moment, which is NIA. Okay, and perpendicular to the loop, and my B is the magnetic field. If we write the magnitude, it will become MB sin theta, like that. Now magnetic dipole we discussed, torque we discussed, potential energy same way. For electric dipole we write the potential energy as minus P dot E. Okay, that is minus P E cos theta. Here we write as minus M dot B minus MB cos theta. SHM of a dipole, moving coil galvanometer. Now SHM of a dipole, let us take magnetic field is there, okay, like this, in this direction. Your dipole initially you can say in the stable equilibrium, it will be like this. This is my dipole direction. If you displace it a bit, it will oscillate like this to and fro. So the torque is MB sin theta is equals to I into alpha. For angular oscillations, we write alpha as omega square theta. Sin theta, if theta is very small, sin theta we nearly like as theta, right, as theta. Okay, it is like this now. theta got cancelled. From here we got my omega. And from omega I can say the time period comes out to be 2 pi by omega. Now, okay, same funda in moving coil galvanometer. Current sensitivity, voltage sensitivity is like the angular displacement per unit current is the current density, current sensitivity, the angular displacement, okay, of the, you can say the pin of the moving coil galvanometer per unit voltage is my voltage sensitivity. Now, there is a spring of torsional constant, let us take C. So, that torque C theta is equal to torque due to the magnetic field, that is mb sin theta. There sin theta is nearly equal to 90. So, sin theta nearly equals to 1 for moving coil galvanometer. M is NIA B, like this. Okay. So, from here I say theta by I is equals to NAB divided by C. Okay, so this became my current sensitivity. If you divide both sides with the resistance of that, it will become V here. Okay, so I can say theta divided by V is equals to NAB divided by C into the resistance. This is my voltage sensitivity, current sensitivity and voltage sensitivity. Quick derivation. Now this was the question which I was talking about. Here three conductors they mentioned. Previously in JEE Mains they mentioned only, two conductors used to mention, how much is the force and all. They mentioned three conductors now. What you need to do? Write the force and the direction due to each of them and then take the resultant. Simple thing. Three long straight wires carrying current are arranged mutually parallel as shown in the figure. So, these three wires are like this. The force experienced by 15 centimeter of wire Q is. Now, I need force on this due to the other two. First of all, let us talk about the direction. What will be the force due to, what will be the direction due to P? They are carrying current in the opposite direction. P will repel. So, the force due to P will be in this direction, Fp. Now, due to these two, they are carrying current in the same direction, they will attract. So, this Q, basically this R will be attracting it, this. So, this will be the force due to R. See this, both the forces are coming in the same direction. First thing I got this. So, when I say that my net magnetic field force, that will be equals to Fp plus Fr. How we write the force? Force per unit length we know, that is mu naught I1 I2 divided by 2 pi d. This formula we know now. I am going to use that. Okay. Now, if I write Fp, it will become mu naught. This is I1, this is I2, 3 into 1 is 3, divided by 2 pi into d. What is d? 3 centimeter. 3 centimeter plus Fr mu naught I1, I2, 2 into 1 is 1, sorry, 2 into 1 is 2, divided by 2 pi into the d. How much is the distance? 2 centimeter. 2 centimeter like this. This is the force per unit length. I need to multiply that with length also. How much is the length? 15 centimeter. So, 15 centimeter like this. This will become the net force there. सर अभी मैं आपको रोटेशन का लेक्चर देख रहा था. ओके सत्यम, got it. Now here this centimeter unit will get cancelled with this centimeter unit, so I did not convert. So this centimeter is basically getting cancelled directly, and now you can do some basic calculation. This 3 is getting cancelled, this 2 is getting cancelled. Mu naught by 2 pi plus mu naught by 2 pi, mu naught by pi. So this is mu naught by pi into 15 mu naught by pi. Then you can put the values, multiply and divide with 4. What is mu naught by 4 pi? 10 to the power minus 7. So this will become 60 into 10 to the power minus 7 Newton. And this force is towards the right. Both were towards the right. So the resultant will also come towards the right. So this will be 60 into 10 to the power minus 7 towards R. Yes, towards R. I know students, They, those who cram the formulas, they know the formula is mu naught I by mu naught I1 I2 divided by 2 pi d per unit length, but they will get confused with the directions. Okay, therefore it is important to understand the concept as well parallelly. Okay, just remembering the formulas will not help you. Getting it? Is that point clear to you? Even if you don't remember the formula, you can quickly derive, right? The magnetic field due to that mu naught I by 2 pi d. Okay, multiply with the current and the length, you will get the force directly. Need not even remember the formula. The rigid wire consisting of semicircular portion, okay, radius r, two straight sections of wire are partially immersed, okay, these two straights like this. Magnetic field is B naught J, okay. What is J? The magnetic field, okay, in this plane, the magnetic field is perpendicular only, out of that actually. Either it should be K because they are showing outside direction as Z, I think. The magnetic force on the wire, if it has a current I is, yeah, it should be K actually. This is a printing mistake, typing mistake, I'll say. It should be K. Okay, it is shown K here. Now I need to write the magnetic force on this conductor. Which conductor? This, from here to here. Magnetic field is uniform or not? Yes, it is uniform. Then what you can do? Draw the effective length. For this, what will be the effective length? What will be the effective length? This is the effective length directly. This is the effective length. How much is this? 2r. If semicircular was radius r, so this is 2r. Actually, the effective length is 2r. So you can take this conductor of length 2r carrying current like this I. What will be the force? IL cross B. IL cross B, okay, it is out of the plane, magnetic IL cross B. It is in the downward direction, and that is BI into 2R. So BI 2R, the direction is minus of J cap, option 4. Is this clear? Okay, great. Next, a short bar magnet placed with its axis 30 degree with an external field of 800 Gauss. How to convert Gauss into Tesla? Multiply with 10 to the power minus 4. Experiences a torque of this much Newton meter. The work done is in moving it from most stable to most unstable position. Stable position, and what is the most unstable position? Please tell me. This is the magnetic field. This is actually the stable equilibrium in the direction. When the equilibrium is stable, by the way, where the potential energy is minimum. See the formula of potential energy, minus m dot b, mb sine theta. Like this we write the potential energy. When the potential energy will be minimum, when m dot b, mb cos theta, I mentioned it wrongly. Yeah. When the potential energy will be minimum, when cos theta is equal to 1, there the potential energy is minimum. So potential energy is minimum for theta is equals to 0. This is the direction of m, this is the direction of b. This is the minimum condition. Where it will be maximum? It will be maximum when cos theta is minus 1, then it will become plus mb. Okay. So potential energy will be maximum for theta is equal to 180 degree. Means maximum condition will be like this. This is B and this is M. This is the maximum potential energy, or I can say unstable equilibrium condition, and this is my stable equilibrium condition, and the potential energy is minimum at the stable equilibrium condition. Okay, this concept is important, therefore I covered it now. The work done, how much will be the work done in moving it from most stable to most unstable? Means you are going from here to here. What is the work done? Work done is equal to change in the potential energy. What is the potential energy here? Here it is minus mb. What is the potential energy here? Here it is plus mb. Work done is equal to change in the potential energy. What is the final potential energy? mb minus the initial potential energy minus mb. What it is now? 2 mb. This is the work done. Now, okay, what is mb by the way? Here it is given to us. You see, a short magnet when it is placed at 30°, magnetic field is this. It experiences a torque. This. What is torque? What is torque? M cross P. This is the torque. That is my mb sine theta. What was the angle? Placed with axis at 30° with the external magnetic field. So it is 30°. This is given to us as 0.016. So from here I can say mb comes out to be 0.032, isn't it? Yes. 0.032. That I can put here twice of 0.032. I related the formulas for, where it is? Oh, sorry. So keep the formulas which I revised for torque and the, where it was? Yeah. This the torque formula and the potential energy formulas. Both for electric field and for magnetic field, these formulas are important for the electric dipole and the magnetic dipole. So keep these two in mind. Is this point clear? Very less students are there, I think, those who are solving the questions with me. I think most of the students are interested in the recorded one because they can watch that at 1.5x. But even if you try to do that, it will actually take you more than 8 hours. And in my marathon sessions, we cover everything in 8 hours. A uniform magnetic field of 2 into 10 to the power minus 3 Tesla acts along positive y direction. A rectangular loop of side this carries current this in YZ plane. Okay. The current is in anti-clockwise sense with reference to negative x-axis. Magnitude and direction of torque is. This question was asked in 2024. Now, what we need basically? We need the torque. What is torque? M cross B. This is the torque. Okay. Magnetic field is this. What is the direction? Positive y direction. So let us draw x, y and z. So this is x, this is y. The magnetic field is in this direction. This is my B. Now rectangular loop of side this. So my area is equals to 20 into 10, which is 200 centimeter square, or 2 into 10 to the power minus 2 meter square. Clear? Current is this. This is my current. So if I write my M, okay, how many number of turns are there? Not mentioned, take 1 turn. So I into the area 2 into 10 to the power minus 2. So what it is? 0.1. This became my M. But I need the direction also for M. The current is in anti-clockwise sense with a reference to negative x-axis, and this is in YZ plane. So this is negative x-axis. So if I see from here, the current is in anti-clockwise. Anti-clockwise means it will be moving in this direction. If I see from here, moving like this. For that, if you see, this is how the current is moving. So this should be the direction of the M. So M is minus of this I cap. This is the most important point here. Getting that? Okay. So this is my M now. I got what is the magnetic field, and this is the magnetic field, and this much J cap. Now you write the torque, simple. So my torque will be M with a negative sign, cross B. What is B? 2 into 10 to the power minus 3 J cap. I cross J is K. Negative sign is there, so minus K. So it is minus of 0.2 into 10 to the power minus 3. The unit is Newton meter, K cap. So the along negative Z direction, yes, and 2 into 10 to the power minus 4. Yes, 2 into 10 to the power minus 4 along negative z direction. Clear? Hmm. Next question. Okay, it's almost 1 hour. We are continuing the discussion. A coil having 100 turns, area which is 5 into 10 to the power minus 3, carrying current of 1 milliampere is placed in uniform magnetic field. And how much is the magnetic field? 0.2 Tesla. Such a way that the plane of the coil is perpendicular to the magnetic field. The work done in turning the coil through 90 degrees. See, such a way that the plane of the coil is perpendicular to the magnetic field. Let us take, this is the coil, this is the magnetic field. Plane of the coil is perpendicular to the magnetic field, isn't it? Yes, but the direction of M is parallel to the magnetic field. Now we are turning it such a way that such a way that the plane of the coil is wait a minute, carrying current I is placed in uniform magnetic field of this such a way that the plane of coil is perpendicular to the magnetic field. The work done in turning the coil through 90. Now I am turning the coil through 90. So let us take, I turned the coil through 90 like this. So here it is my B now and here it is my M now. Write the potential energy here, write the potential energy here, take the difference. Here the potential energy is 0 because angle is 90. Here what is the potential energy? Okay, you can write it as minus of MB. What is the work done? Change in the potential energy, final minus initial. This is my final, this is my initial, so this comes out to be MB. Now we can put the value of M, we can put the value of B, and we can solve it very easily from here. Next question. A current of 200 microampere deflects the coil of a moving coil galvanometer by 60 degree. The current to cause deflection through pi by 60 degree, pi by 10 degree is, pi by 10 radian is. Okay. Now how much the deflection comes per unit current? What we call that as current sensitivity. Okay. So the current sensitivity, it is the same galvanometer, is going to remain the same. Yes. So current sensitivity is same. When the deviation is theta, current is I. So this we call as the current sensitivity. So theta 1 divided by I1 is equal to theta 2 divided by I2. Simple. What is theta 1? 60 degree. What is I1? 200 microampere. So 60 degree you can convert to that to radian. So pi by 3 and I1 is 200. I am putting in microampere. Get the answer in microampere. What is theta 2? Pi by 10. Here the current is I2. Now from here I can find what is the value of I2. Okay, easy to find from here. Okay, now next we are moving to EMI, and now we are taking a break of let us take 10 minutes. Okay, we'll be back at 5:20. Okay, we are back. Yes. Hello, Asif. Yeah. So next chapter we are continuing now EMI. First thing is how we write the induced EMF as minus of d phi by dt. Now phi can change how? How phi can change? Phi can change when, let us take, when we write phi that is my b dot a. Okay, if I write the it like this, ba into cos of the theta between the two vectors. It is like this. Now B can change. Yes, how B can change? I'm varying the magnetic field with the B is equals to B naught into alpha T, or like that you may get some equation. We can vary the area, how the radius of the loop is changing like this, or sometimes the you can say some other type of stuff, or the how the area is varying with time, that equation is given, or the orientation is varying, the angle between the theta and the angle between the magnetic field and the area vector is changing, how we are rotating that. Okay, so if any of the ways is there, our phi will change. Okay, we'll put phi here, we'll write what is the induced EMF. We are back. Yes, hello, Sumit bro, please bring half-life problem from modern physics. It's not there in JEE Mains. Okay, radioactivity portion is not there in JEE Mains, so we are not doing that today, as this is this discussion is for April attempt. Real problem in EMI, yes, we are going to discuss question on that. Real problem we will have. Okay. Yeah, question now. First of all, the flux, okay, linked with a closed circuit of resistance 8 ohm with time, okay, varies like this. The induced current in the circuit at t is equals to 2 seconds. So first find the induced EMF. How much is that? Minus of d phi by dt. Differentiate it with respect to time. What it will become? 5t square differentiation is 10t minus 36. Isn't it? Yes. Now put t is equals to 2. So it will become 20 minus 36. Solve it. It is 16. I need current. This is my induced EMF. Current is equals to induced EMF divided by the resistance, 2 ampere. You see how simple questions are there. This is 2024 question, 31st June, sorry. Okay, 2024 question. And these type of questions are coming, and if students are making them wrong, it's not good. Somebody may say, sir, what is this? This is very simple question. But NTA is asking simple only. Next question. A conducting circular loop of that is placed in XY plane in the presence of magnetic field, which is this, in SI units. If radius of the loop is 1 meter, the induced EMF in the loop at t is equals to 2 second is n pi volt. The value of n is. Now, the loop is placed in XY plane. So, if I write the area vector, that will be area. How much area? Radius is this. So, pi into r square. This is the area. It is in XY plane. So, the area vector will be perpendicular to that along Z. Okay. So, K cap. This is my area. This is B. So, first write flux. That is B dot A. This is 3t cube J cap plus 3t square K cap. Okay. And A is my pi K cap. Like this. Now, take the dot product. K cap dot K cap is 1. K cap dot J cap is 0. So, this is 3 pi t square. Isn't it? This is my flux now. Find the induced EMF by differentiating it. D phi by dt. D phi by dt will be 6 pi into t. I need at t is equals to 2. So, this will become 12 pi. The magnitude is 12 pi. The value of n is. The induced EMF in the loop at t is equals to 2 seconds is this. So, this becomes a 12 pi. So, n comes out to be 12. Magnitude is needed. Okay. So, minus d phi by dt will be minus 12 pi. But I need magnitude. So, that is 12 pi. And if I compare that with n pi, n comes out to be 12. I hope you are able to get this. A conducting circular loop is placed in uniform magnetic field of this 0.4 Tesla with its plane perpendicular to field. Okay. Means area vector and the magnetic field, they are in the same direction. Somehow the radius of the loop start expanding at a constant rate of this 1 mm per second. It means if I write dr by dt, that is 1 mm per second. This is given to us. The magnitude of induced EMF in the loop at an instant when radius of the loop is 2 centimeter. If I write the flux, what is that? B dot A. What is B? 0.4. Magnitude is 0.4. What is area? Area I can write as pi r square because r is varying. What is the direction of area? Because here it is mentioned is placed in uniform magnetic field, which is plane is perpendicular to the magnetic field. It means plane is perpendicular to the magnetic field. It is in the same direction of B. So, theta I can take as 0. So, this is my flux. This is my flux. Now, what is induced EMF? magnitude d phi by dt. Now, if you differentiate it with respect to time, how will you differentiate it? 0.4 pi, that is constant, d by dt of r square. This is how you are going to write it. How you can write it now further? Multiply with dr, divide with dr. Okay, chain rule. Okay, so multiply with dr and divide with dr. It will become like this. Now, d square differentiation of r square with respect to dr will give us 2r. So this will become 0.8 pi r into dr by dt. Yeah, what I need the magnitude of induced EMF. So this is my magnitude of induced EMF. Now put the values. What is R? This is my R. Where? Yeah, this is my R. What is dr by dt? This is dr by dt. What else? Pi, we know. We can put the value. So this video can be used for CUET preparation. If you want to use it, you can use it, but it is above that level. Okay. But if you are taking help from here, certainly it is good. Next, a coil of 200 turns, the area is 0.220, is rotated at half a revolution per second. Okay, and is placed in uniform magnetic field perpendicular to the axis of the rotation. Means, let us take how I should draw the diagram. In a uniform magnetic field perpendicular to the axis of rotation. So this is the magnetic field. This is the axis of rotation. You can say like this. I am rotating it like this. Area is given to us. Now the maximum voltage generated is this. How we write the maximum voltage generated? First write the flux, differentiate the flux, that will give me the induced EMF. Take the maximum value of the induced EMF. Okay. So how to write the flux? B dot A. This is how we write the flux. Let us take at an instant the angle between B and A is theta. So this is BA cos theta. How the theta changes? It is rotating. Okay. So at any instant, if I write the angle between the two, I can write theta as omega t starting from 0. Okay. So theta as omega t. So BA cos of omega t. It is rotating with omega, na? So the theta between at any instant I can write as omega t. So this is my flux now. If I write the induced EMF, d phi by dt, number of turns is mentioned 200 turns. So number of turns you should also take. So n here like this. Now this is my flux. I need induced EMF, differentiate it. Differentiate it. It will become n b a omega sine of omega t like this. I need the maximum value of this. What is the maximum value of this? N b a omega. Okay, so E induced maximum is N B A omega. What is N? N is this. What is B? B is this. Area, this is the area. What is omega? Half a revolution per second. Half a revolution per second means you are rotating pi radians per second. So omega comes out to be pi radian per second. One revolution means 2 pi angle. Half revolution means pi angle. So you are rotating half revolution per second means your omega is pi radian per second. Okay. Question. Square shaped coil of area this having 600 turns rotates in a magnetic field of 0.4 Weber per meter square. Magnetic field has unit Tesla, okay, and we know flux is having unit as Tesla meter square, which we call as Weber also. So I can say the unit of magnetic field SI unit is Weber per meter square also. About an axis which is parallel to one of the side of the coil and perpendicular to the direction of the field. Okay, so same way, let us take this as the direction of field, and along this, which is parallel to one of the side and perpendicular to the field, we are rotating it like this. If the coil completes 500 revolution in a minute, the instantaneous EMF when the plane of the coil is inclined at 60 degree with the field is, this is the plane, let us take, this is the magnetic field, side view I am drawing now, this is the magnetic field, at an instant this angle is 60 degree. Plane of the coil is inclined at an angle 60 degree with the magnetic field. If you ask me what is the angle between the area vector and the magnetic field, that is 30. Okay. Previously I wrote phi as NBA cos omega t. Okay, like this. Use this. Phi is equals to NBA cos of omega t. Induced EMF minus d phi by dt, which is cos differentiation is minus of sine. Okay, minus minus will become plus, NBA omega sine of omega t. What is n? 600. This is my n. What is b? Where is b? This is my b. Okay. What is A? Area. This is my area. What is omega? So completes 500 revolutions in a minute. Means how much angle in a minute? 500 into 2 pi angle, this much radian per minute. How many radian per second? Divide with 60. So this is my omega, this much radian per second. Then NBA omega we know. Now sine omega t. At that instant when the angle between area vector and magnetic field is 30 degree. So omega t is my 30. This is my 30 degree. Now you will write it as NBA omega sine 30 basically. NBA omega by 2. Now here you can put the values, whatever values are given to us, we will put here, we will solve for the magnitude. Isn't it? Is it easy? Please say something. I think very less students are there to continue the discussion till now. Most of them left just by seeing the questions. Okay, this is what happens. This is what happens when you have to put efforts. Then most of the students are not ready. But if you ask me, how many of you want 99 percentile? Everybody says, sir, I want, sir, I want. Then if I ask, how many of you are ready to attend the entire 8-hour session with the question discussion? Then student will say, sir, we will see, we will try. Then they will try, come for a few minutes, leave the discussion. So 99 percentile is not going to come like that. Charge flow in a circuit. Okay, so how we write? Q is equals to delta phi divided by R. Change in the flux divided by the resistance. That was we can write like this. Okay, because we know induced is equals to minus d phi by dt. Okay, this is the induced EMF. So if I write the induced current, so this is induced EMF divided by the resistance. So d phi by dt divided by the resistance. If you take dt on the other side, I dt, okay, integrated, so this will become minus d phi divided by R integration. So I dt will give me Q. So the magnitude of the charge that will pass will become change in the flux divided by the resistance. Next is Lenge's law. Lenge's law means the direction of induced current will come in such a way that it will try to oppose the change. Okay, it will try to oppose the change. If the flux is increasing, the induced current will come in such a way that it will try to decrease the flux, okay, in a particular direction. If it is decreasing, it will try to increase that in that particular direction. Conducting circular loop made of thin wire has area this and resistance 10 ohm. It is placed perpendicular to time dependent magnetic flux this. The field is uniform in space. Then the net charge flown through the loop during t is equals to 0 to t is equals to 10 milliseconds is. Apply the formula, simple. Delta Q is equals to del phi divided by R. Simple thing. Now, what is phi? B dot A. What is B? This is my B and this is my area. And it is placed perpendicular to the time dependent, means the angle between them is, you can say, 90 degree. Sorry, angle between them is 0 degree, perpendicular to the plane, both are in the same direction. So B into area. What is B? B is 0.4 into sine of 50 pi t into the area. Area is 3.5 into 10 to the power minus 3. Now here you put t is equals to 0 and t is equals to 10 millisecond. Here you find what is your phi 1 and what is your phi 2. Then difference, take the difference and it will become your change in the flux phi. That phi you will put here and divide with the resistance. That resistance is 10 here. So divide with that 10, there you will get what is the value of the induced charge. Okay. Yes sir, ready. Okay. Is the thing clear? Are you able to understand? Here you have to do the calculations. I am not doing the calculation. I just told you the method that you have to follow here. Next question. An insulated copper wire of 100 tons is wrapped around a wooden cylindrical core of cross section area this. Number of tons is this is the area. Two ends of the wire are connected to a resistor. The total resistance in the circuit is 12 ohm. This is my resistance. If an externally applied uniform magnetic field in the core along the axis changes from this to this in the direction opposite, in the opposite direction, changes from this in one direction to 1.5 in the opposite direction. Okay, initially you can say it was 1.5 like this, finally it is 1.5 like this. The charge flown through a point in the circuit during the change of magnetic field will be Q is equals to delta phi divided by R. What is delta phi? Phi is B dot A. My B is changing, so I can say this A into delta B divided by R. Number of turns is also there, so I will multiply with number of turns. What is delta B? 1.5 in one direction to 1.5 in other direction. So delta B is basically 3 here. What is N? This is N. What is area? This is area. How much is the resistance? This is the resistance. Now put the values and solve. Now this question appears to be so much lengthy, you see, okay, so much thing is given, but to solve this you have to just apply the formula. Clear? Great. Next, a coil is placed in a magnetic field as shown in the figure. Okay, a current is induced in the coil B. A current is induced in the coil because B is, okay, this is the induced current. Now induced current direction is given like this. So what should be the case? We have to see the case. Case is outward and decreasing. If the flux B is outward, the magnetic field is outward and it is decreasing, it will try to support it by applying a outward magnetic field. It means yes, there can be the induced current in this direction. This is true. This is true. Second, parallel to the plane of the coil and decreasing, flux is 0. It is not changing then. Third, parallel to the plane of the coil and increasing, this is also not correct. Inward and increasing. If it is inward and increasing, it will try to apply its own outward. Okay, it is outward and increasing. If it is outward and increasing, it will try to apply its own field inward. Okay, but that is not the case. Induced current is not flowing clockwise, it is anti-clockwise. So this is also incorrect. Only option 1 is coming out to be correct here. Sir, how 3T comes? Which you are talking about, Kiran? Can you please mention? A, yes, A is the correct answer here. Sir, how 3? I think which you are talking about? Yeah, how 3? Here when I am saying change in the magnetic field, initially the magnetic field was 1.5 towards right, finally it is 1.5 towards left. How much change in the magnetic field? 0. No. Magnetic field is a vector. If I write B1, you will say it is 1.5 I cap. B2, it is minus 1.5 I cap. So if you write delta B, that is B2 minus B1, okay, minus 1.5 I cap minus 1.5 I cap. So here magnitude comes out to be 3, like this. So when I say delta B magnitude will be 3 Tesla. Sir, is 200 possible in 13 days from 88 percentile? 200 plus is possible. Again I am saying the same thing, that if you really want 200 plus, do you really want 200 plus? Are you ready to put that efforts? Then it is yes. If you are like, I want 200 plus, but I don't want the sacrifice after 200 plus. Okay, if you don't want the sacrifice after 200 plus, I cannot invest so much time in studying. I have to watch some reels also. I have to do this thing also. I have to do that thing also. If you are that type of student, then I'll say no, that is not possible then. Okay, it totally depends on you actually, Tejas. Sorry, not Tejas, Ravi Kumar was asking. It totally depends upon you. Yeah, motional EMF due to translational motion and rotational motion. How we write the motional EMF? V cross B dot dl. This is how we find the polarity. Okay, V cross B dot L, like that. Okay, let us take a rod is like this. Okay, magnetic field is in this direction, the rod is moving in this direction with velocity v. So v cross b dot l, so upper is coming positive, lower is coming negative, and the magnitude comes out to be bvl. So I will replace this rod with a battery like this. Okay, if a rod is there which is rotating about this point like this, let us take the magnetic field is like this. Here the induced EMF comes out to be B omega L square by 2. Now you may say, sir, which terminal is positive, which terminal is negative? So V, let us take the velocity of any point, okay, as in this V cross B dot L. So this is positive, this is negative now. Next question. Yeah, B omega L square. Great. Oh, yes. Next, a conducting circular loop is rotated about its diameter, okay, in a constant angular speed of, at a constant angular speed of 100 radian per second in magnetic field 0.5 Tesla perpendicular to the axis of rotation. So you may say this is the, you can say magnetic field which is 0.5. And the circular loop is there at a constant angular velocity. Let us take this as the circular loop. It is rotated like this, I think. Yeah, 100 radian per second. When the loop is rotated by 30 degree from horizontal position, the induced EMF is this. That is 15.5 millivolt. The radius of the loop is. Similar type of question which we just did. Ravi Kumar, thanks for the answer. Okay, Ravi. But I think you should be ready to do that sacrifice, because that sacrifice is worth, Ravi. Okay, like if you can do that sacrifice, yes, I am ready to put any amount of effort, then I'll say for sure you are going to make that. Okay, that sacrifice is worth actually, because even if you put some extra efforts and then later you see those efforts made a incredible change in your life, okay, then you'll say that sacrifice was worth. Okay, understand that. And yes, like if you will not make sacrifice now, you will have to make greater sacrifice later. And the result will also not be the same, even if you make greater sacrifices. Okay, so the somebody says, I heard somebody from my relative was mentioning that golden opportunities in life are very less. If you grab those golden opportunity, you are going to make huge difference in your life. But if you miss those golden opportunity, then you have to put so much hard work, extra hard work for few, small things, petty things like that. So better to grab golden opportunity, okay, at the right time. This is the right time, grab it. This is the time. Okay, coming to the question. When the loop is rotated by 30 degree from the horizontal position, the induced EMF is this. Okay, constant angular speed this. Okay, so you may say the loop is rotated 30 degree like this, the magnetic field is like this. How we write the flux? Let us take at any instant this angle is theta. So this angle between area vector and this will also be theta. So if we write the flux will be BA cos of theta, which is omega t. Now number of turns is also given. Number of turns is also given. I think it's not given. Anyways, constant velocity this, the magnetic field is this, perpendicular when the loop is rotated by this, the induced EMF is this much below, the radius of the loop. Anyways, number of turns is not given, so we will take number of turns as 1, n is equals to 1. Now differentiate it, d phi by dt will give you B A omega sine of omega t. What is B? This is my B. What is A? A I will put as pi r square. What is omega? Omega is this is my omega. What is sine omega t? Okay, omega t is 30 degree. Okay, theta is 30, so my omega t is 30 degree. Pi is given as 22 by 7 and what is B? B 0.5. Put the values, you will get the answer. Of course, yes, you got the point, I hope. The magnetic field in the region is given like this, B is equals to B naught x by A. Now this magnetic field is non-uniform, that is not constant, that is changing with x. A square loop of side A, side D is placed with its edge along x and y like this. The loop is moved with constant velocity v naught I cap. Okay, this is moving with constant velocity v naught I cap. The induced, the EMF induced in the loop is. How to find the EMF induced now? One of the fundamental thing is at a distance x as a function of x, write what is the flux, differentiate that flux, that will give you induced EMF. Another way to do is that this is one conductor, this is another conductor, this is another, these 4 conductors are there. Separately you can see how much induced EMF will be in each of them and then take the resultant in the loop. Now one thing is, see carefully, magnetic field is changing along x, along y the magnetic field is not changing, along y the magnetic field is not changing, the magnetic field is only changing along x. Now whatever induced EMF will come in this, will there be any induced EMF in this by the way? If you do V cross B, okay, it is, wait a minute, V cross, it is moving along the length, there will be no induced EMF in this. Okay, V cross B dot L when you do, and it is also moving along the length, no induced EMF in this. Only induced EMF will be in this length and in this length, in this length and in this length. Okay, so you can say at any time, I can say this and this, it is moving with velocity v naught, it is moving with velocity v naught like this. What is, if I take x is equals to x here, what will be x here? A, okay, d, sorry, okay, the distance is d. So here my x is equals to x plus d. What will be the induced EMF in this? BVL. What is B there? Put x is equals to d. Okay, put x is equals to x plus d. Okay, so induced EMF will be B V into the L. Similarly, induced EMF in this, let us take this as E2. Induced EMF here, B, what is that? Into V into the length L. How much is that? That is D. How the polarity will be? V cross B dot L. Okay, so V cross B like this. and like this. So when you take the resultant, these two are in opposite sense, so you will subtract them. So if you subtract them, it will become just B naught V D square by A. Okay, B naught V D square by A. That is the first option. Okay, Tejas, I hope you got it. Yeah. Next, this is the moving you can say real type of problems that you are talking about, Asif was talking about. Now here this conductor is moving with some speed V in the magnetic field like this, the direction is shown. So how we will say? We will say there will be some induced EMF. How that will come? V cross B dot L. So I can replace it with a battery. How it is connected? With a battery which is connected like this, BVL. V cross B dot L. Up is coming positive, so polarity plus will come up, minus will come down for the battery like this. Now length is 1 meter, AB completes the circuit as shown. The area of the circuit is perpendicular to the magnetic field. Thus if the resistance of the total circuit is this, the force needed to move the rod right with a constant velocity 1.5 s. Basically I need now how much will be the force on this conductor when it is moving. So the current will come basically in this direction I, so current is I. Now this conductor is carrying a current I in this direction. What will be the magnetic force? IL cross B, IL cross B. This is the magnetic force. So I have to apply same and equal force in the opposite direction. Why so? Because I want the acceleration to be 0. It is moving with constant velocity V, with a constant velocity V, it means the acceleration is 0. If acceleration is 0, this applied force has to be equal to the magnetic force that is being applied there. So this F comes out to be BIL. Now what is I? EMF divided by the resistance. Okay, this is my EMF BVL. So I is equals to BVL by R. Put it this I here. So F comes out to be B into BVL by R into L. So it is B square L square V by R. Now put the values. What is B square? B is 0.1. So 0.1 square. What is L? L is 1 meter. So 1 square into what is V? V is 1.5 divided by how much is R? R is 2. So divided by 2. Okay. Clear? Great. Next. Conducting bar of length L is free to slide on two parallel conducting rails as shown in the figure. Now you see what happens. There was a student, they just few minutes before he was saying that I want question on rails, and now we are having that question and he went away. Actually he was not, he don't want to put efforts, and like he want the teacher to just take some question according to him quickly. You don't have that much time to wait. Anyways, the conducting bar of length L is free to slide on the parallel conducting rails as shown. Now this bar is free to slide. Two resistors R1 and R2 are connected across the ends of the rails. These are the two resistors R1 R2. There is a uniform magnetic field B pointing into the page. Okay, the external agents pull the bar to left with at a constant speed V. The velocity V is in this direction. The correct statement about the directions of induced current I1 and I2. Okay, we need to tell just the direction. Now first of all, let us see, I'm also here sir. Yeah, Kiran is there, we know that, I know that. So let us see how the battery will come first. Polarity of the battery. So V cross B dot L, lower will be positive, so I will replace it like this. Now if it is like this, the current here it will come like this. On the other side it will go like this. Okay. So, which one is clockwise, which one is anti-clockwise? Can you tell me? Now, this I1 current is clockwise, this is clockwise, okay, and this I2 current is anti-clockwise, this is anti-clockwise, this is I1, this is I2. So, I1 is clockwise and I2 is anti-clockwise direction. Fourth option is coming. Now, you can do this by, you can see just by seeing the polarity, as this rod is moving to the left, the flux inside this loop is decreasing, okay, it will induce its current in such a way that the flux inside increases. It means it should come clockwise. Lenz's law. Now here, this conductor is moving towards left, flux inside this loop is increasing, it will apply its own field such that flux inside decreases, so it will apply its field outside like this, oppose the change, so it is coming outside. Think that by Lenz's law also we can directly tell the polarity. Next question. A rod of length 60 centimeter rotates with uniform angular speed, which is 20 radian per second, about perpendicular bisector in a uniform magnetic field 0.5 Tesla. You can say this is perpendicular bisector. I am rotating it like this. In a uniform magnetic field which is 0.5 Tesla. The direction of magnetic field is parallel to the axis of rotation. Axis of rotation is perpendicular. So, the magnetic field is also perpendicular. You may take magnetic field inside or outside, doesn't matter. Let us take like this, inside. The potential difference between the two ends of the rod, between this end and between this end, the potential difference is 0 volt. There is potential difference between center and this end. There is potential difference between center and this end, but these two ends have the same potential. How? See this. I mentioned that magnetic field, the induced EMF is B omega L square by 2 due to rotation. Okay, which one is positive, which one is negative? Here you see V cross B dot L. So this is positive, this is negative. Here you see it is moving like this. V cross B dot L. This is positive, this is negative. Actually, these two are having same polarity. Magnitude will be same, polarity is the same, the potential difference between the 2 points is 0 actually. Simple. Now, induced electric field, self-inductance and all, you already know. Let us solve some questions directly. L minus L di by dt, energy density we write as half epsilon naught E square due to electric field, okay, and due to magnetic field we write as B square by 2 mu naught. This is the energy density due to magnetic field, here energy density due to electric field. Coming to questions directly. Copper wire is wound on a wooden frame whose shape is that of an equilateral triangle, okay. So, wooden frame is having the shape of an equilateral triangle like this. The copper wire is wound on this wooden frame. If the inner dimensions of each side of the frame is increased by a factor of 3, keeping the number of turns of the coil per unit length of the frame as same, means n is same, but what happened? You increase the dimension by 3, means here this is L, you made 3L. You made it 3L, you made the dimensions to be 3 times. Then the self-inductance of the coil will, how the self-inductance of the coil will change? Now, important thing to understand what is given here is the number of turns per unit coil per unit length of the frame is same. Number of turns per unit length of the frame is same. Number of turns, that is not changing. Now, how the self-inductance should change? Now, we can relate with solenoid. Okay, if a solenoid is there, okay, like this. If I ask you How much is the self inductance for this? How to find that? You know, the magnetic field is mu naught into Ni. Okay, I am writing the flux first. Okay, so into the area of cross section A into the total number of turns. Okay, this is B, and this area into number of turns, this gave me total flux phi. Phi you can write as Li. Okay, so basically my L comes out to be mu naught N into A into the number of turns. Now you see number of turns per unit length, or I can write this as N as number of turns per unit length into the length. So mu naught N into number of turns per unit length into the length, like this. So it will become N square. Okay, A into L. So basically we say self inductance per unit volume is mu naught N square. Try to understand this here. Important point. Self inductance per unit volume is equal to mu naught N square. Okay, this is mu naught N square. Okay, now what is happening is, how the area of cross section is changing? Area of cross section is changing. If side is getting 3 times, area will be proportional to L square. So area of cross section is getting 9 times. If here area of cross section is A, here the area of cross section will become 9A. Okay, and what else is remaining the same? Number of turns per unit length is remaining the same. Okay, number of turns per unit length, this what we call as small n, this small n is same, means this is same, this is same, this area is changing. Is the length also changing? Yes, length will also change. How the length will change? Means on the total length of that, how that will change? Okay, so when you are making that, you can say when you are winding that, okay, making the total number of turns across that, okay, now your you can say total parameter here is getting 3 times. Yeah, total parameter is getting 3 times. So the length on which you can wind will become 1 by 3 times. So here this length of the solenoid is getting 1 by 3 times. Try to understand in the 3 dimension like this. This length perpendicular to it. Here when you are winding it up like this, let us take you wounded for length, some length L, maybe capital L. Here when you are winding the same wire, here your parameter 3 times, it means you will be able to wind that up to 1 by 3rd of that length. So here that length actually is getting 1/3. This is also changing. Area is getting 9 times, this is getting 1/3, so the product will get 3 times. I took time to explain this because this was important to, like, not important, it was difficult to understand. Therefore, I explained it nicely. I hope now this complete idea is there with you. Okay, next. The current in inductor is given like this. The magnitude of induced EMF produced by the inductor is 12 millivolt. That self inductance of the inductor is simple. How we write the induced EMF? Minus LTI by dt. Just we need the magnitude. Okay, I need L. Current is given. I can find di by dt from here. Differentiate that. Di by dt is, if we differentiate this expression, it comes out to be 3. Now put di by dt 3 here. L comes out to be induced EMF divided by 3. So this is 12 millivolt divided by 3. You'll get the answer in millihenry, that is 4 millihenry. 4 millihenry. Yeah, that answer was 3 there. Kiran, great. As per the given figure, the value of VAB at this instant is, I need the potential difference between A and B. So what you can do is, start from A, start walking like this towards B. Okay, let us do that. I'm starting from A. So when I'm at A, I'll say the potential as VA. Now, first I moved in direction of current through a resistor. The potential will drop by how much? IR. So minus IR. So minus 2 into 12. Then through inductor, minus L di by dt. Minus L into di by dt. What is di by dt? Minus 1. This is my di by dt. Minus L di by dt. Now through the battery, I am going from positive terminal to negative terminal. Potential is dropping, minus 12. Then I reached at B is equal to VB. I need VAB. VAB is VA minus VB. So VA minus VB, that is my VAB, comes out to be, take this, this and this all on the other side. This is 12, then it will become minus 6, then it will become plus 12. This comes out to be 18 volt. Black Mystery, good evening. You are late today? I was waiting like nobody from the previous live. Got it? Next, the self produced EMF of a coil is 25 volt. When the current in it is changed at uniform rate of 10 ampere to 25 ampere in 1 second, the change in the energy of the inductance is, how we write the energy stored in the inductor? Half Li square. See, we write energy stored in the inductor as half Li square. Now, induced EMF is 25 volt. How we write induced EMF? V is equals to minus L di by dt. This is how we write the induced EMF. Okay. Magnitude is there. Okay. Just take the magnitude. So the magnitude is 25 into L. Instead of di, I'll write delta I divided by delta t. Write this in average form. 25 is equal to L into, what is delta I? It is changing from 10 ampere to 25. So 25 minus 10 divided by, in how much time? In 1 second. So divided by 1. So my self inductance came from here. How much is that? 25 divided by 15. That is 5 by 3. So self inductance is coming 5 by 3. Now put it here. I need the change in the energy. So delta E, when I'll write, that is half L I2 square minus I1 square. Like this. Now put the values. Half, what is L? 5 by 3. What is I2? 25. What is I1? 10. Yes. So this became the change in the energy. Sorry for the delay, sir. No issues. I had school today. Oh, you had school today? I think your exam should be over now. What you are getting? 437. One mentioned 437. Another is saying 540. Just check the calculations. 5 by 6 into a square minus b square, either you can do like that, or if you remember it is 625, it is 100, so you can say 525. Now you can solve it. I think it should be point something. Huh? Next, series parallel combination of inductor. You already know that current distribution in series parallel, you know, L1 I1 is equals to L2 I2, so that current will be distributed in inverse ratio of the inductors. And mutual inductance. How we find the mutual inductance? Due to one of the coil, see the flux induced in the other coil and write that flux as phi into I from the, as due to one coil, find the flux due to flux induced in the second coil. Okay, that we say as flux in 2 due to 1, and write this as my mutual inductance into the current in the first coil. Mutual inductance of second with respect to first or first with respect to second is same thing. Okay. No sir, still one more on 25th. Okay, computer science. Yeah. I think that is there. Oh, okay. No issues. So mutual inductance of 2 due to 1 or 1 due to 2 is same. Okay, and yes. So sometimes what happens is finding mutual inductance of 1 due to 2 is easier, but you cannot find 2 due to 1. Sometimes it happens. Okay, I'll show you some of the cases. Okay, so if you do that way, then you know in the question they will say find the mutual inductance of this due to this, but you should understand both are same. Okay, here also we are finding mutual inductance of this solenoid due to the outer one or outer solenoid due to the inner one. Anything you can do and you can find it. Just coupling coefficient. If two mutual inductance are root L, let us say the self inductance of first is L1, self inductance of second is L2. Okay, so the mutual inductance we can write as K root of L1 L2, where my K is the coupling coefficient. Okay, this is my coupling coefficient. If two coils are perfectly coupled means coupled in such a way there is no leakage of the flux, their mutual inductance, there this coupling coefficient becomes equal to 1. And if like we consider ideal what we call as transformer, yeah, in ideal transformer coupling coefficient is 1, there is no leakage of the flux. Generally there is some leakage of the flux. Okay, mutual inductance between two coplanar concentric coils. Yeah, let us check here. You have to find mutual inductance between the two. So what you can do is, here these two concentric coils are there. It will be given that radius of A is very less as compared to B. Then you can consider how you write the flux of coil 2 due to 1. Okay, take a current here I. Due to this current, what will be the magnetic field at center? Mu naught I by 2R. Now this area is very small, field is almost uniform everywhere into the area, pi a square. This becomes the flux. Write this flux as mutual inductance into the current I. From there you got your mutual inductance. Mutual inductance between two coaxial parallel coils. There can be two coaxial parallel coils also. Yeah, this question was asked in my time. Yeah, I remember it. 2013, there was this question, I think. Two coaxial coils were there, and there we need to find the mutual inductance. And here also it is, that assumption is given to us. Let us take, this is B, this is A. Here it is given to us that A is very small. A is very small, so you can consider almost, you know, that magnetic field here will be uniform. Radius is very small, na? So magnetic field here due to this coil will be almost constant. Take current, some current I here. What will be the magnetic field here? B is equals to mu naught I into R square divided by 2 into R square plus x square to the power 3 by 2. This is my distance x. This is the magnetic field. Flux will become pi, the area here, pi a square into this field. This you will write as the mutual inductance into the current. So this here current will cancel. Actually mutual inductance is independent of the current. Okay, it depends upon the dimensions of the coil, how they are placed, okay, what the distances and all other things are there. It depends on that, not on the current that is passing. This question, many times in NTA such questions are asked. They will give two coils, one circular they are giving here, another you can say square loop is giving. One time they mention two square loop, one time they mention two circular loop. Okay, so only limited variations are there. Find the mutual inductance of the arrangement when a small circular loop of wire of radius r is placed inside a large square loop. Here this assumption is there. This assumption has to be there, otherwise you cannot solve. The loops are coplanar and their centers coincide. Okay, these loops are coplanar and their center coincide. Now you have to find, let us take, I'll take current I in this outer loop. Due to that current, you have to find how much will be the flux. For that, first I need how much will be the field there. I'll consider that field almost constant everywhere, multiply that with pi r square to get the flux. So what is basically field here? B. This is a straight line. This angle is 45 degree. This angle is 45 degree. Magnetic field will be mu naught I by 4 pi into the perpendicular distance, that is L by 2, into sine of 45 plus sine of 45. This became my magnetic field at center. Due to this one, I need due to the complete loop, so into 4. This became my magnetic field. I need flux. Multiply this with area, pi r square. I got the flux. Write the flux as mutual inductance into the current. Simple. Okay. And then from here, I can cancel this I. And sine 45, that will become my root 2. Everything else is there. You'll put the values. If the values are given, if variables are there, you can find in terms of the variables. Next, a small circular loop of wire of side L is placed inside a large circular loop of wire of side, that is L, which is equal to L square. Here equal to L square is given, so you may say that is very, very small. That assumption has to be there. Consider that assumption there. The loops are coplanar and their centers coincide. The value of the mutual inductances. Now I am having this square loop and I am having this square loop. Due to this square loop, I already wrote the magnetic field. What was the magnetic field? Mu naught I by 4 pi r into 2 sine 45 into 4. This was the magnetic field. Multiply this with area L square. This becomes the flux. This is mutual inductance into the current. So I got my mutual inductance in this case. Clear? Just follow the standard method. Pass current in one of the square loop, one of the loop, okay. Find the flux due on the other. Write that flux as phi into m into I. Simple thing. Sometimes they may say find the mutual inductance of inner loop due to outer, or they may say find the mutual inductance of outer due to inner. That doesn't make any difference. It's the same. This is what you have to understand. Okay. Now the thing is, can you find the mutual inductance of outer due to inner? That is difficult because you cannot find how much will be the flux if you pass current here and how much will be the flux here everywhere. Okay. Doing those calculations are not easy. Okay, those calculations will be difficult, but we can do other way around. Therefore, we solved it like this. Now, growth of current in LR circuit. Similar to LC circuit, if anything which is increasing, that will be of type maximum value into 1 minus e to the power minus t by tau. If anything is of form which is decreasing, maximum value into e to the power minus t by tau. What is tau here? L by R. So here my current will be increasing, so I will be the maximum current that will become when inductor will be at steady state. Inductor at t is equals to infinity behaves like a short circuit. At t is equals to 0 behaves like a open circuit. Maximum value into 1 minus e to the power minus t by tau. Tau is equals to L by R. Okay. Current you can find or potential you can find accordingly. Decay of the current. If some inductor is having some current at some instant and now you can say you close the switch, so what will happen with the time? Only resistor is there, battery is not there, the current will decay. How the current will decay? Current will decay like its maximum value into e to the power minus t by tau. If anything is decaying, it will be of form e to the power minus t by tau. Maximum value into e to the power minus t by tau. 128. Okay, that's great. Did the calculations. Question. Figure shows the circuit that contains 3 resistances and 2 inductors. This question was asked in 2026. Okay, January attempt, this year only. The reading of the ammeter at the moment when K is turned on. Okay. This is the condition. Okay. Is there any current anywhere? No. No current is there in the circuit. Now you just turn it on. This is an inductor. At t is equals to 0, inductor will behave like open circuit. No current will pass through this. Here also it will behave like an open circuit. No current will pass through this. Only current will go like this, come like this. Okay, how much is the current now? Voltage is 9 volt, resistance is 9 ohm, so the current will be 1 ampere. Inductor cannot change the current suddenly. Try to understand. Inductor has its limitation. Inductor cannot change the current through it suddenly. Okay, so initially the current was 0. Now you are switching it on. At t is equals to 0, inductor will say I will not allow the current. Okay, so that current will be 0. It will behave like open circuit. Yes, the answer is 1 ampere. Next question. Three identical resistors with resistances of 12 ohm, okay, this, and this. Two identical inductor with self inductance 5 millihenry, okay, this and this 5 millihenry are connected to an ideal battery 12 volt as shown. The current through the battery long time after switching. Now you close this switch. T is equals to 0, inductor behave like open circuit, but T is equals to infinity, inductor behave like short circuit, okay, short circuit this, short circuit this. Now these three resistors are in parallel. If they are in parallel, all three resistors, the equivalent will be R by 3. What is R? R is 12. So this total is 4 ohm now. How much will be the current? What we need? The current through the battery. Current will be 12 by 4, 3 ampere. These steady state questions which are asked by NTA both for capacitors and inductors are one of the most easiest and simplest questions, and still many of the students, because they fear from LR circuit na, they will see this question and they'll say, oh my god, what they have asked, they will skip it. And there is nothing to solve here, you see. Just by looking at it you can solve this question, just by looking at it. Yes, just by looking at it you can say, oh, steady state, short circuit, 3 resistors in parallel, R by 3. R by 3 is 4. Divide with 4, 3. For the given circuit, the current through battery 6 volt just after closing the switch will be. Close the switch. Now what will happen? This is inductor. T is equals to 0, inductor behave like open circuit. Open circuit means close it. It will not allow the current. So no current will pass through this circuit. This circuit is useless. Current will pass like this. How much resistance is? 6 ohm, 4 plus 6, both are in series na. How much will be the current? 6 by 6, 1 ampere. This question was asked in 2022. Next, the time taken for magnetic energy to reach 25% of maximum value when solenoid of resistance R and inductance L is connected to a battery. Okay. This is how you have connected to the battery. Magnetic energy, how we write? Half Li square. Magnetic energy reached 25% of maximum, means 1/4 of the maximum, means current is half of the maximum. I max by 2. I need time. How we write the current? I is equals to I naught into 1 minus, it is increasing na, it is minus T by tau. Like this we'll say. This is I max by 2, so it will become 1 by 2 is equals to e to the power minus T by tau. So e to the power T by tau is equals to 2. Take log both sides, so it will become T by tau is equals to ln2. T is equals to tau ln2. Tau is equals to L by R ln2. L by R ln2, first option. Sir, inductor is replaced capacitor. What happened? Okay, here you are talking about, I think. Here if you replace inductor with capacitor, see this. If you put capacitor here, at T is equals to 0, capacitor will behave like short circuit. Yeah, capacitor will behave like short circuit. Then I will short circuit it like this. Then I will say the current will pass through this also. This is 4 ohm, this is 4 ohm, 4 parallel with 4, 2 ohm. Like that I will be solving this. Getting it? My capacitor and inductor, they behave, opposite way. At T is equals to 0, capacitor is short circuit, inductor is open circuit. At steady state, capacitor is open circuit, inductor is short circuit. Opposite behavior. Next question. Okay, now I'll see oscillation. So I'm having an inductor, capacitor is charged initially. I close this switch. Now what will happen? There will be no dissipation of energy in this case because the resistor is not there na. Resistor is the one who dissipates the energy. Capacitor and inductor, they cannot dissipate the energy. Only resistor can dissipate the energy. Is there any resistor? No. Energy will remain the same. Sometimes it will be stored in capacitor, sometimes it will be stored in inductor, or both will be having some portions of the energy, and that will oscillate like this. Okay. So here the charge will oscillate, the current will oscillate, or I can say the energy will oscillate. Okay, all will oscillate, everything will oscillate. Therefore, we call it as LC oscillations. So if I write charge here, charge on the capacitor, it is like Q naught into cos of omega t. At t is equals to 0, my charge on the capacitor is peak charge, that is Q naught. Okay, at any time t, it is like this. If I write current, current behave will be opposite. Okay, at t is equals to 0, the current will be 0. So it is Q naught by omega, okay, sine of omega t, like this. Just to differentiate it. Okay. So you can say at t is equals to 0, the current is 0. Okay. When current is maximum, the charge will be 0. When charge is maximum, the current will be 0. It is like spring mass oscillations. Sometimes the energy is stored as the potential energy of the spring. Sometimes the energy is stored as the kinetic energy of the spring. And in general, the combination of the two. But the total energy remain the same. Questions. Capacitor of capacitance 100 microfarad is charged to a potential of 12 volt and connected to 6.4 millihenry inductor to produce oscillation. The maximum current in the circuit will be, okay, this is it is charged to 12 volt and connected to this current. Now energy will remain the same. Initially only only capacitor is having energy. How we write the energy of the capacitor? Half CV square. Okay, so initially only capacitor is having the energy. When the current in the inductor is maximum or current in the circuit is maximum, total energy will be the energy that is stored in the inductor, half Li square. Okay, like this. From here I can say what is the value of I. So I, the maximum current, comes out to be C by L. Okay, root of C by L into V here. Yeah, V I can take as common. Okay, sorry, square root, that is V. This is root of C by L. Now put the values. Put the values. What is C? C is 100 microfarad. What is L? 6.4 milli, like this. And what is V, by the way? V is 12. Yeah. Okay, sir, inductor is late. Okay, I answered that question. Moving ahead. RMS. Okay, now we are moving to the next chapter. What's the time now? It's 6:30. It's 6:30 and let us take a break now till how much? 45 will be back. Okay, 15 minutes break we are taking. Or let us take 10 minutes. Let us. (6:41). We'll be back. चल रही है स्लाइड चल रहा है back for the next chapter. Okay. RMS value of alternating current and EMF. If there is a sinusoidal wave, okay, we know the RMS value is peak divided by root 2. How we define RMS? RMS is a root of the mean of the square. Okay, so first square that, then take the mean, then take the root. This is how it is defined. Okay, and if let us take you have some constant. Okay, constant RMS will be that only. Okay, some constant value is there, its RMS will be that value only. And if you are having, let us take two RMS values. Okay, summing up it like this. So the net RMS value is, if let us take you are having two currents. Okay, let us take my I1, maybe some constant 10 plus 5 cos omega t. Okay, like that. Then what we do is the net RMS is equal to root of first RMS. Okay, I can say I1 RMS square plus I2 RMS square, like this. Take the root of that, that will give you the net RMS value. Huh. Yes, alternating current at any instant is given like this. The RMS value of the current is, now its RMS is 6 only. Its RMS is 56 divided by root 2. It's a sinusoidal thing. Okay, so I2 RMS is equal to root 56 divided by root of 2. That will give us root of 28. Now when you have to write the RMS, so I'll say I net RMS is equal to root of I1 RMS, okay, that is 6 square plus I2 RMS root of 28 square. Okay, so this will become 36 plus 28. $64, that comes up to be 8. Yes, Swapnil. Next question. Alternating voltage 200 sin 100 pi t is applied to a purely resistive load of 50 ohm. The time taken for the current to rise from half of the peak value to the peak value. It will be of sinusoidal nature. Okay, current is rising like this, half of the peak value to the peak value. Sine curve is going from half of the peak value to the peak value. How much is this phase? How much is the phase here? Okay, sine 30 is 1 by 2. Okay, so 30 degree to 90 degree. So this phase is basically 60 degree. Okay, so this phase we will write as omega t. So pi by 3 is equals to omega t. From there, I'll get what is the value of t. Putting that. Okay. Alternating voltage applied to a resistor. You already know these things. Fundamentals applied to an inductor. Now one thing, let me mention. Here when the current will come, it is a pure inductive circuit. In inductor, the current will lag the voltage by 90 degree. The voltage will lead the current by 90 degree. For capacitive, the current will lead the voltage by 90 degree. The voltage will lag the current by 90 degree. These things should be remembered. Now coming to the questions. An alternating voltage which is given as 200 sin 100 pi t is applied to a purely resistive load of 50 ohm. The time taken for the current to rise from half of the peak value to the peak value. Same thing, okay, same thing I did now previously. The same thing you have to do. Here the phase is, how much is the phase changing? That is by 60 degree. Okay, 60 degree you can write as omega t and you can solve it. It's the same question. Next question. As shown in the figure, an inductor of inductance 200 millihenry is connected to an AC source. Okay, this is the AC source. EMF 220 volt and frequency 50 hertz. The instantaneous voltage of the source is 0 volt when the peak value of the current is this. The value of A is, here it is mentioned, the instantaneous voltage of the source is 0 volt. At a particular instant, this source voltage is 0, okay, when the peak value of current is this, and at that particular instant the peak value of the current is this. Now you have to understand, both are sinusoidal. The current is sinusoidal, the voltage is sinusoidal. The voltage is lagging behind, sorry, the current is lagging behind the voltage by 90 degree. If one is sine, another is cosine. Okay. So if one will be 0, another will be at its peak value. This is what is mentioned. That is 0, it is at its peak value. This much is the peak value. How much is the peak value, by the way? Current I peak is equals to V naught divided by XL. V naught is 220 as the peak value. AC source. This is not the peak value. By default, whatever voltage is given, that is the RMS. Voltage or current they are mentioning, that is the RMS. Okay. Inductor of inductance, this is connected to AC source of 220 volt and frequency. So this is my actually RMS value. Okay. So if I have to write peak value, so I will take the voltage as peak here, which is 220 root 2 divided by, what is XL? Omega into L. Omega into L. And then what is omega? Omega is, this frequency is 50 hertz. Omega is 2 pi f, 100 pi. Okay, put it here. So this is 220 root 2 divided by, omega is 100 pi, so 100 pi into the inductor L. Where is L? L is this 200 millihenry. So 200 into 10 to the power minus 3. Clear? Now just we have to do some calculations to solve it. 10 to the power minus 3 is there, 3 zeros will get cancelled here, and pi, option is in terms of pi, don't put the value of pi. You can solve it further very easily. Next question. The RMS value of conduction current in a parallel plate capacitor is 6.9 microampere. The capacity of the capacitor is this. If it is connected to 230 volt AC supply with an angular frequency of 100 radian per second will be, how much is the current? So that will be V divided by XC. This is how we'll say. What it is? 230 volt. This is my V, and current is given as 6.9 microampere. So write it. XC we will get from here. What is that? V is 230 divided by 6.9 microampere. 6.9 microampere. This is XC. XC we will write as 1 by omega into C. Okay. And omega is 600 radian per second. It's already given in radian per second. Put it there. So C will be equal to this 1 by, what is that? 600. Whole thing you will take here. 230. Here it is 6.9 into 10 to the power minus 6, like this. Yes. Getting it? Next question. In a circuit consisting of capacitance and generator with alternating EMF, that is E naught sin omega t, VC and IC are voltage and current. Okay. The correct phase diagram for such circuit is, now this is only capacitor. We know for capacitive circuit, the current will lead the voltage by 90 degree. Now see the circuit in which the current is leading. It is not correct. It is not correct. Here the current is lagging. Here the current is leading. Current should lead the voltage by 90 degree in a capacitive circuit. Now series RLC AC circuit. The theory you already know. I'm just moving ahead. Some questions. For the series LCR circuit connected with a 220 volt 50 hertz source as shown in the figure, the power factor is A by 10, the value of, okay, so it should be alpha, I think. Power factor is alpha by 10. What is the value of alpha? How we find the power factor? You draw the impedance triangle, you find phi, the phase difference between voltage and current. From there, you can find, say, what is your cos phi. Cos phi is the power factor. Phi, how will you find? Draw the impedance triangle. Okay, this is XC minus XL. This is R. So here XC is given, XL is given, XC minus XL, if I say 10 phi here, that will be equal to XC minus XL divided by R. XC minus XL is 150 minus 70 is 80 divided by R is 60. So this is 4 by 3. I need cos phi. If 10 phi is 4 by 3, cos phi will be 3 by 5. 3 by 5 means 6 by 10. Option comes out to be 6. Is this clear? Moving ahead. An AC source is connected in given series LCR circuit. The RMS potential difference across the capacitor of 20 microfarad is across this. How much is the potential difference? How we say? That is I into XC. Simple. So I need I. How to find I? I is equals to V by Z. Okay. What is Z? Z is equals to root of XC minus XL whole square plus R square. So basically I need what is my XC, I need what is my XL, R I already know, that is 300. So first of all let us find XC and XL. So if I say XL, XL is my omega L, omega is 100 into L, L is 1. So this is 100 ohm. XC is 1 by omega C. So 1 by 100 into C is 20 micro. Micro means 10 to the power minus 6. So 10 to the power 6 will go here. So this will become 500 ohm. Yes, it is 500. Now find Z. Z is equal to root of XC minus XL 400 square plus R square. R is 300 square. So this became my 500 ohm. I got Z as 500. Find here I as V, which is I need RMS. Okay, so I am putting here RMS only. 50 is the RMS value divided by 500. So this become 1 by 10. I is 1 by 10. So VC RMS is equals to I RMS into XC. That is 1 by 10 into XC, that is 500. So this comes out to be 50 volt. Next question. In the circuit, RMS value of the current through the resistor is. So I'll say I RMS is equals to V RMS divided by Z. Z is equals to root of XC minus XL whole square plus R square. What is XC and XL? 200 and 100. So if you do it, 100 square plus what is R? 100. So this comes out to be 100 root 2. So I got my Z as 100 root 2, put it here. I RMS is equals to V RMS is 200 root 2 divided by 100 root 2. So this comes out to be 2 ampere. 2 ampere, that is the first option. Next question. An LCR circuit contains a resistance of 110 and supply of 200 voltage at 300 radian per second. angular frequency. If only capacitance is removed, the current lags behind the voltage by 45 degree. If only inductor is removed, the current leads by 45 degree. Okay, the RMS current flowing in the circuit will be. Now simple thing is there. XC has to be equal to XL and that has to be equal to R. This knowledge gives us, okay. If capacitance is removed, current lags the voltage by 45 degree. Okay, means tan phi is equals to 1. Okay, X is not there. I got XL is equals to R from this data. From this data, I got my XL is equals to R. In the second case, I got my data as XC is equals to R. Therefore, this condition we got, okay, and contains resistance of 110. Anyways, the RMS current. Now, if I write RMS current, first of all, let us find Z. How will I write Z? Z is equals to root of XC minus XL whole square plus R square. Now, XC is equals to XL, so this part is 0. Now, this R, what is R? R is 110. So, if you take root, it will become 110 only, square of that. 110, we are getting Z as R only. So, the current comes out to be VRMS, what is that? 220 divided by 110. So, this comes out to be 2 ampere, which is second option. Swapnil is asking, sir, I have 80 percentile in shift 1, so I need 99 percentile in second attempt. So, what can I do to prepare to cross that percentile? Swapnil, you have to put good efforts and you have to cover all your backlogs, do all the PYQs, okay, cover all the backlogs. If you do these things, you will be able to get 99 percentile. Do all the PYQs by understanding the concept. If you are ready, you will get. An inductor stores 16 joule of magnetic field energy and dissipates 32 watt of thermal energy due to the resistance. Due to this resistance, this much energy is dissipated. So, if I say how much is the energy dissipated in AC circuit, I square R. Okay, I square R is given as 32. The inductor stores 16 joule of magnetic field energy. Half Li square is 16. When an AC current of 2 ampere RMS frequency 50 Hertz flows through it, I is given to us 2. Frequency is given 50 Hertz. The ratio of inductive reactance to its resistance is, okay, so I need XL divided by R. How much it is? These two I can divide. I square will anyways get cancelled. Okay, I square and I square are getting cancelled. Okay, so this will become 2 R divided by L. This is 32 divided by 16. This comes out to be 1. I am getting R is equals to L. Okay, oh, and XL by R, that is my omega L divided by R. R and L are coming equal. What is omega? Omega is 2 pi f. So, it is 2 pi into the f, which is 50. So, this is what is 100 pi. What is pi? 3.14. So, this is 314. Next question. Okay, you got 3, sir, which you are talking about? Okay, I think you deleted your question now. Anyways, an AC circuit as shown in the figure is driven by AC source generator, okay, a square wave. The output pattern monitored by CRO will look like. So, this square pattern is coming. Here this is resistor, here this is capacitor. How the output voltage across the capacitor will go? The capacitor will charge, okay, and then the capacitor will discharge, then the capacitor will charge and then it will discharge. So the potential will increase, then decrease. Okay. First the potential will increase. Wait a minute. What is happening here? This is RC circuit only, by the way. Yeah. AC source that is generating square wave. Now I need potential across this. Okay. How across this I can relate with potential? I can relate with that potential with the charge, and then accordingly I can say how much will be the potential that will be coming across that. Now when the square wave is coming, you can take it like this maybe, or it is coming in the same like this. Increase. Okay, the potential will increase, then it will drop, then it will increase, then it will drop due to the resistance, then it will increase. Here when it is, peak is coming, the potential will increase, try to rise, it will go like. Then okay, the source is not there, here it is 0, then what will happen? Through the resistor it will dissipate the energy, so it will decrease like this, then it will increase again it will increase, then it will decrease like this. Okay, so this type of shape will come, so we will say fourth will be the correct fit here. Fourth will be the correct fit. Okay, yeah, that was 314. Here the answer is D, yes. So fourth will be the, you can say, correct fit. May not be very exact, just we need to have an idea, okay, how it should vary. The LC circuit, okay, in LC circuit the inductor L is this, capacitor is this. If a voltage V, this is given like this, is applied to the circuit, to the current, circuit, to the current in a circuit is given by, okay, how the current will vary. This is the LC circuit, L is given like this, capacitor is given like this. This is how the voltage is given. Now how we mention the current? So first we will see what is XL, we will see what is XC, okay, X and XC we will see, and then accordingly we will see what is my total impedance, and from there I will say either my current will be lagging by 90 degree or the current will be leading by 90 degree, depending upon which comes out to be greater, whether XC is greater or XL is greater. So first I will say XL, that is my omega L. Omega is 314 into L as 40 millihenry. Then I will find my XC, which is 1 by omega C, 1 by 314 into C. What is C? C is 100 microfarad. I got my XC and XL. Now I will see which one is greater or which one is lesser. Okay, and getting it, first of all I will find the peak value. What is that? V, that is 10. So I peak will be 10 divided by XC minus XL mod of this, because this will be my impedance. I will got my peak, and then I will see which one is greater. Accordingly my sine or cosine will come. Now cos will come only, na, that will be perpendicular to that only. Okay, anyways, leading or lagging, that thing will come. Okay, average power in series AC circuit, how we write the power dissipated? V naught Vrms into Irms into cos of phi, where this we call as the power factor. Okay, I can write this as, in terms of the peak values only, I peak into V peak divided by 2, root 2, okay, so that will become 2 into cos phi. I can write like this also, or I can write this as I square into R. R I can write in terms of Z also there. Next, power factor, I already discussed. Coming to questions now. Coming to questions. In an AC circuit, voltage and current are given like this respectively. The average power dissipated in one cycle is, how we say the power dissipated? The average power Irms into Vrms into cos of phi. What is Irms? This is my I. Irms will be 100 by root 2. What is Vrms? That is 100. Peak is 100. 100 by root 2. So this is Irms into Vrms into cos of the phi. Phi is the phase angle between the two. how much it is? Phase difference between the two, that is 60 degree. Cos 60 is 1 by 2. So 1 by 2 will come from there also. Next question. A series AC circuit containing an inductor 12 millihenry, a capacitor 120 microfarad and a resistor 60 ohm is driven by AC source of 24 volt and 50 hertz. The energy dissipated in the circuit in 60 seconds is. So the same thing, we'll find the power. Okay, power into time, that is my energy dissipated, simple thing. Now write it. AC circuit containing, this is the inductor. Okay, so XL is equals to omega into L, 50 into 2 pi into L is 20 millihenry, this much ohm. XC is 1 by omega. Okay, omega is 2 pi f. Wait a minute. Yeah, 50 into 2 pi into 120 microfarad. This is my XC. And what is the value of R? This is my R. Now you need the impedance triangle, or directly also you can say without impedance triangle, the power dissipated is equals to IRMS square into R. That way also you can say. Okay, IRMS you can write as VRMS divided by Z. Okay, and Z you can write as root of XC minus XL square plus R square. From there you will get power. If you get power, you need the energy dissipated, that is power into time. So energy dissipated is equals to power dissipated into the time. What is the time? 60 seconds. So into 60. Okay, Swapnil is solving each and every question. That's great. Next, resonance in LCR circuit. Resonance happens, okay, when XC is equals to XL here. Okay, and my impedance will be equal to R only, and the peak current will be at its maximum value, that will be equals to V peak divided by R. The frequency for the resonance is omega naught is equals to 1 by root of LC. That thing you know. Next question. In LCR circuit, the capacitance is changed from C to 4C. To keep the resonance frequency unchanged, the new inductance should be. What is resonance frequency? Root of LC. If capacitance is getting 4 times, the inductance should get 1 by 4 times. Okay, so inductance should be reduced by, okay, anyways, my inductance L dash should be L by 4. So it is reduced by 3L by 4, or reduced to, anyways, reduced by L by 4 anyways. So reduced to, it should be reduced to 1 by 4L. This, okay, we did this. It is coming again. Why it is coming again? Okay, so just a minute, we need to change the PPT. तो चेंज कर देना यार, उसमें तो दोबारा से वो आ गया, दोबारा से वो PPT खोल रही है आगे, ऐसे कैसे होगा? I'm the only person attending this session. Yes, you are the only person attending this session. Sir, could even remember our names cause very less members are attending the session. Nobody is attending this session. A message and visible. Now it is visible. Actually, we are back. Okay, you are back. Now this is a statement question from AC circuits. Maximum power is dissipated in circuit containing an inductor and capacitor and a resistor connected in series with a source when resonance occurs. Okay. Now when resonance occurs, what happens? The current is maximum. How we write the current, by the way? We write the how we write the power dissipated, by the way? That is I square R. This is how we write the dissipated power. In AC also I am saying. Okay, here we will say power as the current as RMS current. Okay, I square R. Now when this will be maximum? When I is maximum. So if this is maximum, this dissipated power will be maximum. So when this RMS current will be maximum? When Z is minimum. When the Z is minimum? When my XC is equals to XL, okay, the resonance condition happens basically. At resonance, we know the current is maximum. Okay, this is maximum at resonance. This is maximum at resonance. So we can say that statement 1 is true. Yes, this is true. Second statement, maximum power is dissipated in circuit containing pure resistor due to zero phase difference between current and voltage. Yes, when the phase difference is zero, okay, between the current and voltage, okay, yes, this is actually the resonance condition, okay, then maximum power is dissipated. Statement 1 is true and statement 2 is also true. Both are true. Next, here we are having inductor and a capacitor are in parallel with a resistor. What is given to us? 110 volt 50 hertz AC source is connected to the circuit. The current through the resistor resistance 55 ohm at resonance in the circuit. Now when the resonance will happen, what will be the impedance of this parallel combination? This parallel combination will give us, what it will give us? Infinite impedance it will give us. Okay, it will give us infinite impedance and this will behave like open circuit. The current in this will become zero. Okay, anyways, AC questions we have sufficiently solved. Now I am moving ahead with the EM waves topic from displacement current. So how we write the displacement current? I displacement is equals to, first of all, Ampere circuit law, integration of B dot dl is equals to mu naught into I enclosed. This is how we wrote it. Okay. Then Maxwell mentioned that there is some issue with this equation and he explained what is the issue in this equation, and that issue is this current should involve the two currents, that is conduction current and the displacement current. That displacement current is equals to epsilon naught into d phi e divided by dt. This is how we write the displacement current. This basics you got. Coming to the questions now. An alternating voltage of amplitude 40 volt, frequency 4 kilohertz is applied directly across the capacitor of 12 microfarad. The maximum displacement current between the plates of the capacitor is nearly. I think this question we already did. Maximum displacement current means when the current is the conduction current is maximum, then only the displacement current, that continuity is there. Now the conduction current will be equal to the displacement current. Okay, whatever will be the current here, the same amount of current is passing through this displacement between these plates. So this is my displacement current. Basically this conduction current is equal to displacement current. So I can find the maximum conduction current, that is my maximum displacement current. Okay, Vp divided by Xc. Simply Okay, these questions you can solve for your practice. These are the 4 Maxwell's equation. Now coming to EM waves, we know in an electromagnetic wave, the electric field and magnetic field, they are oscillating in direction perpendicular to, in planes perpendicular to each other, and the direction of propagation we write as E cross B simply. Yeah. Linearly polarized electromagnetic wave is given like this: is incident normally on perfectly reflecting wall at Z is equals to A. Choose the correct option. Frequency of electromagnetic wave is, now it is talking about the reflected. When reflection will happen, the frequency will not change. Frequency will remain the same. Whatever is the frequency of this, the same frequency of this. This is omega. Okay. Here it is talking in radian per second. This is incorrect. This is incorrect. Omega is equal to 2 pi f. Okay. So if you talk in hertz, okay. So this is omega. Omega I'll write as 2 pi f. From there I'll get the frequency f. The transmitted wave will be linearly polarized electromagnetic wave in vacuum is incident normally on a perfectly reflecting wall. Okay, Z is equals to this. Z is equals to A. Here it is talking about translated. Then the reflected wave will be, if I talk about the reflected wave, the direction of propagation will be opposite. Yes, the direction of propagation will be opposite. And what else? This seems to be, transmission will not happen because it is perfectly reflecting. Okay, if it is perfectly reflecting, total wave is reflected, transmission will not happen. Wavelength, if I talk about, this is K. Okay, 2 pi by K, this is my lambda. Okay, so 2 pi by K, we can do, what is that? 2 pi into pi is 3.14 divided by K, that is 1.8. How much it is coming, by the way? Not 5.4. This is incorrect. Only third comes out to be our correct option. Yes, C was correct. Kiran is back, I think. A plane electromagnetic wave is moving in free space with velocity this, and its electric field is this, where J cap is the unit vector along y-axis. The magnetic field vector B of this, of the wave is, okay. So we need, what is B? So C is this, the peak value of electric field we know. Now how to relate the peak value of electric field and magnetic field? Like this. From there we will write B, E by C, divided solve for B. Now when you write the expression for magnetic field, this part will be as it is. Here you got your B naught. Now direction. What is the direction of propagation? Direction of propagation is plus Z axis. It means E cross B should be along K cap. Okay, accordingly we will solve it. The dielectric constant, we know how to relate the speed and all. I'm moving ahead. Okay, anyways, I'm skipping many of the questions. In electromagnetic waves, these are the simple things you already know. And now I'm moving to next, which is ray optics. Law of reflection you already know. Image of a point object found by plane mirror is at the same distance behind the plane mirror. Angle of deviation, a ray is coming, it will be reflected like this. This is my total deviation. If two plane mirrors are there, okay, then 2 pi minus theta is the deviation. Velocity of image, the two components, the parallel component will remain the same, the perpendicular component will invert itself. An object is placed at a distance of 12 centimeter from in front of a plane mirror. The virtual erect image is formed by the mirror. Now the mirror is moved by 4 centimeter towards the stationary object. The distance moved by the position of the image is, simple thing it is. Draw the diagram. Object is placed at a distance of 12 centimeter in front of plane mirror. Here is 12 centimeter. The virtual and erect image is formed by the mirror. Where the image will be formed? Here. Now the mirror is moved by 4 centimeter towards the stationary object. Here. How much this will remain now? 8. Okay. The distance which the position of the image will shift. Where the image will be? Here. 8 centimeter. So initially the image was here at 24. Finally the image is at 16. 8 plus 8. How much is this shift? This is 24 minus 16, 8. So the shift by the image is 8 centimeter. Okay, plane mirror stuffs are easier. Coming to questions, some questions on curved surfaces now. Okay, I'm planning to wind this up quickly because hardly any student is watching this discussion. So we are not going to pull this too long. Okay, if no response is there, I am winding it up. I was planning to solve 250 questions, but will not be solving that. A convex mirror of radius 30 centimeter forms an image that is half the size of the object. The object distances. So you can use the magnification, half the size of the object. Magnification, how we write? Minus v by u. Okay. Magnification is 1 by 2. 1 by 2 or minus 1 by 2. This is a which mirror? Convex mirror. It is always positive. And then we'll use the mirror formula 1 by v plus 1 by u is equals to 1 by f. This we will use. Radius of curvature is 30 degree. So focal length is equals to our 15 centimeter plus 15. Okay. Accordingly, we will put it and we will solve it. Thin cylindrical rod. Okay. I'm moving ahead further. Skipping refraction. Okay. Apparent depth. You already know TIR, you know. Now some questions of the TIR now, simply. Consider light ray traveling in air as incident on medium of refractive index root 2n. The incident angle is twice the refracting angle. The angle of incidence will be. This is my refractive index. Initially it was traveling in air. Okay. It was coming like this. It went like this. Here the refractive index is root of 2n. The incident angle is twice. So this is I. This angle is I by 2. Now use the Snell's law. 1 sin I is equals to root 2n sine of r, which is I by 2. Simple. Okay. What will be the apparent depth? 6 by mu 2, 6 by mu 1, add. Okay. The two apparent depths. So my apparent depth d will be equals to apparent. Okay, it will be 6 divided by 3 by 2 plus 6 divided by 8 by 5. These okay, anyways, moving ahead. Prism. We are moving to prism now. Some questions of prism. Yeah, minimum deviation questions. A monochromatic light is incident at a certain angle on equilateral triangular prism and suffers minimum deviation. If the refractive index of the material of the prism is root 3, the angle of incidence will be. Minimum deviation happens. What will be the condition at minimum deviation? Okay, sorry. Let us take, this is normal here. The ray comes like this, goes like this. Okay, so at minimum deviation we know this R1 is equals to R2 and this R1 is equals to R2 and that is equals to A by 2. This is equilateral triangle, so this is 60. It means this has to be 30 and this has to be 30. Now use Snell's law here. Let us take this angle of incidence as I. Now write it. Use Snell's law here. Sin I is equals to mu sin R sin 30, which is 1 by 2. So I will become 60 degree. Next question. A thin prism P1 with an angle of 60 degree. Now when the thin prism comes, how we write the deviation? Mu minus 1 into T. Mu minus 1 into A, simply. Okay, this is the deviation for the thin prism. Remember it. Take the angles to be small. Our general formula for deviation is mu is equals to sine of A plus del by 2 divided by sine of A by 2. Like this is the general formula, and from here if you take all the angles to be very small, okay, sine A plus del by 2 as A plus del by 2, sine of A by 2 as A by 2, and then you solve it, this deviation, you can say this formula comes out to be like this. Getting it? Now let us solve this question. A thin prism P1 with angle 6 degree made of glass of refractive index 1.54 is combined with another prism P2 made from glass of refractive index 1.72 to produce dispersion without deviation. Dispersion without deviation, it means my deviation is equal to 0. You are putting two prism to make the deviation 0, so you certainly put like this. So deviation, positive deviation of one is equal to the negative deviation of the other, then only they are balancing. So mu 1 minus 1 into A1 is equals to mu 2 minus 1 into A2. Now put the values and from here you will get. The exit surface of a prism with a refractive index n is coated with a material having refractive index n by 2. Here the refractive index is n. Now we have coated it somewhat like this, and here the refractive index is n by 2. When the prism is set for a minimum angle of deviation, it exactly meets the condition of critical angle. When the condition of minimum deviation happens here TIR happens. Here TIR happen when it will happen? Sin theta critical is equal to 1 by mu relative is 1 by 2. Okay, mu relative is 2 here. Okay, so here my theta critical comes out to be 30 degree. It means, let us take, it was incidenting like this, reflect. Here this angle is 30 degree and this meets the condition of minimum deviation. So this is 30, this is also 30, this angle is 60 degree. Okay, so the angle of prism comes out to be 60 degree. Okay, we know that R1 is equals, R1 plus R2 is equals to A. Minimum deviation happened, R1 is equals to R2 and that is equals to A by 2. So A comes out to be 60 degree here. Refraction from spherical surface. Okay, so here we have to use the formula of spherical surface reflection, which is mu 2 by V minus mu 1 by U is equals to mu 2 minus mu 1 divided by R. Simple. Apply it, you will get it. Now some lens. Okay, this is 2026 question. A biconvex lens of formed by using two thin plano convex lens as shown in the figure. The refractive index and radius of curvature are also mentioned in the figure. When an object is placed on the left side of the lens at a distance of 30 centimeter from the biconvex, okay, the magnification will be. So here if we put at a distance of 30 centimeter, how much is the magnification? Magnification we will write as V by U per lens. But to find my u I know, to find v I need the focal length. Now this is made up of two lengths. Okay, so let us take the left one is having focal length f1, right one is having focal length f2. So 1 by f equivalent is equals to 1 by f1 plus 1 by f2. For to find f1 and f2, for each we will use the length maker formula, that is 1 by f is equals to mu minus 1 into 1 by r1 minus 1 by r2. Accordingly, we will find f1, we will find f2, we will put here, find the equivalent, use the equivalent to find v, then take the ratio of v by u. Okay, I am moving ahead here. Velocity of image and all. Coming to the questions. Now, how we write the power? Power is equals to 1 by focal length. Okay, if you cut a lens from the half, if you use the lens maker formula, you write it like this. Okay, 1 by r1 minus 1 by r2 like this. Here r1 is equals to r2, and if you use that with sign convention, it becomes 2 by r here. If you cut it with half, it will become 1 by r. Okay, it means if this lens is having power p, okay, when you cut it with half, this lens will have power p by 2. Okay, this lens will have power p by 2. This lens L3 will have the same power because its focal length is same. It will have power p only. It will have power p by 2. It will have power p by 2. Power of L1 is p. Power of L2 is this is incorrect. Power of L2 is p by 2. Power of L3 is p by 2. Power of choose the incorrect. Okay, incorrect is only 1. This is incorrect, so this is our answer now. Same size images are formed by convex lens by other than 2026. Okay, same size images are formed by convex lens by a convex lens when the object is placed at 20 centimeter or at 10 centimeter. Okay, these type of questions you can easily do just by using the lens formula. Velocity also you can relate. So I am skipping some of the parts. Find the distance of the image from object formed by the combination of these lenses. So what you can do, due to each of the lens you will see how the image is formed. Okay, and accordingly you can find for the total one. Now you see, for the first, focal length is 10. What is the object distance? 30 centimeter. So find the distance of the image for this lens. That image will behave like object for this. Okay, then again find its image. That image will behave like object for this, and sequentially we'll solve it. Combination of lens and mirror. Simple microscope, two formulas. Okay, when the image is formed at d, when the image is formed at infinity. Okay, LD by f naught Fe is for at d, this is the magnification. Okay, for infinity it becomes d, instead of d by Fe we will write 1 plus d by Fe, L by f naught into 1 plus d by Fe. A compound microscope formula also you know, telescope formulas I mentioned here. Okay, this is for compound. Mistake I mentioned for simple. This is for compound. So compound microscope formulas I mentioned. For telescope, you know, f naught by Fe for at infinity. These are the formula based questions, so I am skipping these, and these are also formula based questions. Now we are moving to wave optics. Let us do some of the questions on wave optics. Light emerges out of a convex lens when a source of light is kept at the focus. If the source is kept at the focus, parallel rays will come. For parallel rays, the wavefront will be plane. So fourth option is there. Okay, here which phenomena cannot be explained by wave theory of light? Refraction, explained. This is explained. Diffraction is only explained by this. So only option is Compton effect, and you know here we treat the photon which is coming like particle, the radiation which are coming like a photon. Okay, Two coherent monochromatic light beams of intensities I and 4I are superimposed. The difference between maximum and minimum possible frequencies. How we write? I max is equals to root of I1 plus root of I2 whole square. I min is equals to root of I1 minus root of I2 whole square. Just take the difference, we'll get. Young's double slit experiment. The position of fifth bright fringe is 5 centimeter. The distance between slit and screen is this. Monochromatic light used is this. The separation between the slits is this. Okay. For fifth bright fringe, how we write the position? Y is equals to 5 lambda d by d. Simply. From here, I need d. So d will become 5 lambda d by y. I'll put the values. I'll get the answer. So, why, sir, you are so fast? Yes. We have increased the speed. Initially, I was thinking to solve everything, but hardly anyone is there live here. Okay, so I'm just planning to wind this discussion up quickly. Using okay, a Young's double slit experiment, a monochromatic light of wavelength this produces a fringe width 0.5 mm. If another monochromatic light of wavelength this is used, the separation between the slits is doubled, then the fringe width will be, okay, fringe width, how we write? Lambda d by d. Okay, now accordingly you can see which thing is changed, how it is changed. You can take the ratio. Okay, so beta 1 by beta 2 will be equal to, d is kept as same, so lambda 1 by lambda 2, and here it will become d2 by d1. That's all. What happened? Okay, this only 101 pages, so let us change the PPT. I have a PPT but शुरू कर दीजिए. Yes, with the next question on YDSC Young's double slit experiment. Slit arrangement. Slits are separated by gap of 0.5 mm. Okay, so this is D, and the screen is placed at a distance of 0.5 meter from them. This is capital D. The distance between the first and the third bright fringe is formed when the slits are eliminated is this. Okay, first and the third. Third is 3 lambda d by d. First is 1 lambda d by d, and this is given to us as how much is? Okay, this is what we need basically. Yeah, so this becomes my 2 lambda d by d. This is the distance. Lambda we know, capital D we know, small d we know. We can put the values and we can solve it easily. Okay. Next. In Young's double slit experiment, monochromatic light of wavelength 5000 is used. The slits are 1 mm apart and screen is placed 1 meter away from the slits. The distance from the center of the screen where the intensity become half. Now, how we write intensity? I is equals to the maximum intensity, which is our 4 I naught. I naught I am taking as individual, into cos square phi by 2. If it is half, it means this is 2 I naught. It means cos square phi by 2 is equals to 1 by 2. It means cos of phi by 2 is equal to 1 by root 2. Phi comes out to be 90 degree. Now from phi you find the path difference. Delta x is equals to 2 pi by, phi is equals to 2 pi by lambda delta x. From here you find what is delta x, and delta x is equals to d sine theta. From there you will get what is your phi following this sequence. Okay, these are similar type of questions. We are moving ahead. Okay, here whenever there is a transparent sheet, the additional path difference introduced due to this is mu minus 1 into t. Okay, YDSC we did. Now I am moving ahead. Thin film interference, then single slit diffraction. Some questions on single slit I am taking now. In the measured angular separation between the second minima to the left of the central maxima and third minima to the right of the central maxima is this 30 degree. How we write? We write the minima sin theta as L lambda by A. Theta to be small, we write theta nearly equals to L lambda by A. Second to the left, third to the right. So this is the slit. Here and here. This is 2 lambda by A. This is 3 lambda by A. The total angle will become 5 lambda by A. And this is given to us as 30 degree, which is pi by 6. From here we will solve for other things. Okay. Anyways, this polarization things, Malus law you already know, but let us solve one question on this. Beam of unpolarized light of intensity I naught pass through Polaroid A, then another Polaroid B. So first I naught is coming, then Polaroid A is there. This was unpolarized, so this will become I naught by 2. Another Polaroid B which is oriented so that the principal axis makes 45 degree relative to A. So here between these two the angle is 45 degree. So here it will become I naught by 2 cos square 45. Okay, so final intensity will become I naught by 4. Okay, these are polarizing question only, these polarization question only, which you know. Brewster's law, tan theta is equals to mu. Okay, now coming to photoelectric effect, some questions on that. We have started modern physics now. Monochromatic light of frequency 6 into 10 to the power 4 is produced by a laser. The power emitted is this. How many number of photons per second on average are emitted? So we write on an average per second. So power we will write as number of photons into energy of each photon. This is how we'll write. So n will become power into lambda divided by hc. Now everything is given. Power is this. Frequency hc by lambda you can write, or in terms of frequency you can write h into mu. Here frequency is given, so I'll write h into mu. So this is my mu. And h is known to us, we can find easily what is the number of photons, sorry, this power divided by h into mu. Okay, photoelectric effect. Let us do some of the fundamental question quickly. Yeah, Astitva there, it was I by 4. A light source of wavelength 2 illuminates a metal surface and electrons are ejected with maximum kinetic energy 2 electron volt. If the same surface is illuminated by a light of wavelength lambda by 2, then the maximum kinetic energy of the ejected electrons will be. We just write the equation first. Kinetic energy is equals to hc by lambda minus phi. This is how we write. Condition 1. Case 1, okay, the maximum kinetic energy is 2 electron volt. So 2 electron volt. Wavelength is lambda. If the surface is illuminated with a light of wavelength lambda by 2, and the work function is given to us as 1 electron volt, so minus 1 electron volt. This is the first thing. Second, what is mentioned, when it is made lambda by 2, the maximum kinetic energy of the ejected electrons, how much it will be? So k dash hc divided by lambda by 2 now, minus 1 electron volt. From here I can say hc by lambda is 3 electron volt. If you put here 3, it will become 6. 6 minus 1 is 5. Okay. Skipping photoelectric effect and all. Coming to some questions on de Broglie now. You'll get the these notes. Okay, you can solve those questions which I am skipping by yourself. An electron of mass m, initial velocity this, electric field is this. If the de Broglie wavelength is lambda naught, then after time t it will. How the de Broglie wavelength will change? I will find the velocity after time t. Okay, then accordingly I will say. So what is initial? Lambda is equals to h by mv naught. This is the initial condition. Finally, lambda dash will be equals to h divided by m into velocity. Velocity will be root of this velocity square plus the perpendicular component that will be due to the electric field. Okay, E by m into the time square. This is square of this. Okay, so from here we can solve what is lambda in terms of lambda naught. So that's it. We know that de Broglie wavelength is equals to h by p, the momentum. Okay, these simple questions we have already solved. This stuff you can do easily. Now moving further, distance of closest approach and all. Next, Bohr's model. Considering Bohr's model of hydrogen-like atoms, the ratio of radius of fifth orbit of electron in lithium and helium is. How we write radius? Radius is equals to a naught, the radius in the first Bohr's orbit, into n square divided by z. This is how the radius varies. Okay, so relation we know, accordingly we can take the ratio and we can say what will be my radius. Same stuff here, speed is related, so v is proportional to, or v is equal to v naught, okay, to z by n. V naught is the velocity in the first Bohr's orbit. Okay, anyways, this angular momentum you already know. I am skipping the fundamental things. Electron revolving in nth Bohr orbit has magnetic moment that comes out to be proportional to the my orbital number. How? Magnetic moment is equals to I into A. I will write as Q divided by the time period. This is my current. Area I write as pi into r square. like this. Time period we can say 2 pi r by v, okay, pi r square. This 1 r is getting cancelled. V is proportional to z by n, okay. R is proportional to n square by z. Here this magnetic moment comes out to be proportional to n. Proportionality of n is there, that's all. Okay, here during the transition of electron from state A to C of Bohr orbit, the wavelength is emitted as 2000, it becomes 6000 when the electron jumps from state B to C, okay. So here we can say the energy difference between A and B plus B and C is equals to A and C. Accordingly, 1 by lambda and 1 by lambda 1, 1 by lambda 2, they can be related. Okay, Moseley's law and all. So now we are moving to some next chapter, some questions from nuclei. Ratio of density of oxygen. Now we know density remains same. Density is independent of the mass number. The ratio comes out to be 1. Percentage growth in surface area. We know that radius is proportional to, how we write radius? Radius is equals to r naught into atomic mass to the power 1 by 3. Okay, this is how we write. So my radius is proportional to a to the power 1 by 3. Proportional to a to the power 1 by 3. So if you talk about surface area, that is proportional to radius square. So surface area will be proportional to a to the power 2 by 3. Mass number to the power 2 by 3. Now here we will see how the mass number is changing. Accordingly, we will see how much change is coming in the surface area. Okay, now coming to Q value. So we will find the mass defect and then that will multiply with 931.5. We have to find mass defect in U, then we will multiply that to 931.5. Accordingly, we will say how much will be the Q value. Okay, so here how much will be the mass defect? A is getting converted to B plus D. So what is the mass of A? That is 238.05079 U minus mass of B plus mass of D. This is the mass of B, 234.04363 plus mass of D is this 4.00260. I got the mass defect in U, in terms of U, multiply this with 931.5 mega electron volt. From here we can write. Okay. Anyways, all these questions are one of the basics. Now I am moving to some of the questions from semiconductor. And then we will close this discussion. Acceptor level of p-type semiconductor is 6 volt. The maximum wavelength which can create a hole, means hole pair can be generated if that energy has to be equal to 6 volt. Okay, so the maximum wavelength that can generate will be having energy equal to this. So Hc by lambda is basically equals to 6 electron volt. Hc is given to us as 1242. 1242 divided by 6. This will be my lambda max. Okay. Yeah. Dynamic resistance. When we talk about dynamic resistance, we know resistance is equals to, for a metal if I say, that is V by I. Here the resistance is not constant because the slope is continuously changing. So you use here dynamic resistance, which is del V divided by del I. So you take what is del V, you write what is del I, divide them to find the answer. Okay, then some diode circuit question. Diode in forward bias will behave like short circuit, ideal diode. Ideal diode in reverse bias will behave like open circuit. But if here the resistance in forward bias is mentioned, so it's not an ideal diode, then you consider the resistance of that diode in forward bias. Okay, Here if we see which one is forward bias, this is forward bias. So this is reverse bias, this will not conduct. Its resistance in forward bias is 50 ohm. So consider here 50 ohm. Now you can say 50 and 130, 180 and 120. Total resistance comes out to be 180 plus 120, which is 300 ohm. So the current will be 6 divided by 300. That's all. Anyways, these type of stuffs you already know. This we did one question on this. Solar cell and all. So important part I'm moving now, which is Zener diode. Let us do some important question on Zener diode. Let us do this question. For the given circuit, the power across Zener diode is, how much will be the power across Zener diode? We say power is equals to potential into the current. Okay. So power across Zener diode will be Vz into Iz. What is Vz? Vz is 10 volt. Okay. So 10 into, how much is Iz? How to find that? See, this is 10, this is 20, so this is 14 volt. If this is 14 volt, here I'll say the current will be equal to 14 divided by 1, which is 14 milliampere. Okay, this is 14 milliampere. Across this, the potential is 10 volt. How much this current will be? 10 volt divided by 5K, this is 2 milliampere. Okay, this is 10 volt divided by 5K. So this is 2 milliampere. Here it was 14 milliampere. So it means how much current will pass here? 12 milliampere. So this will become 10 into 12 and into 10 to the power minus 3. Okay, 120 milliwatt. Simple. Okay, some logic gates questions. Let us do some logic gates question. Consider the following logic gate circuit. The output Y is equals to 0 when this output has to be 0. Okay. Either I can start from this side and then see the output, make that output 0, or I can see from the output and then come on the input side. It is 0. It means output of the AND gate will be 1. Output of the AND gate will be 1 when both are 1. Okay, this output is 0. Output of AND has to be 1. Okay, this not is there, na? This is NAND. So here it has to be 1, here it has to be 1. Here it has to be 1, here it has to be 1. If this is 1, both has to be 1. This is 1, this is 1. Okay. Now, if this is 1, this will be 0 and this will be 1. Certainly, we are getting 1 here. So, both has to be 1 and 1. A is equals to 1, B is equals to 1. Simply. Okay. Okay, these logic gates question also you can do, and that's all. We are ending this discussion. We are ending this live. I think hardly any student was there, so we quickly winded up this discussion. Thank you all. We'll meet in the next live. Bye-bye. And